Hey Lawler, how you doing? Good to see you. Guys, do I have a doozy for you today? Good. How am I? I am honestly, I am extremely frustrated. I'm not gonna lie. Let me I'm just getting set up here, guys. I'm sorry. But let me see here. But I'm good. Well, like overall, I'm good. I'm just frustrated with the topic that I have to cover. Um, but yeah, everything's good here. Everyone's everybody's happy and healthy and all that, so all good, all good. But yeah, I'm gonna get into it in a second. I'll just get started. It's gonna be, it's gonna be a long stream. I'll react on punch cards. Yeah, react on punch cards. Ain't that the truth, huh? Get a drink in a sec. Thanks, Lawler. Okay, I gotta get properly proper for this. What's up, Moldy on YouTube? Hello, everyone on X. This is gonna be, I don't know. Yeah, I'm frustrated. So it might be a bit of a long stream. As a matter of fact, I know it will be. Gotta put on the hoodie. I've got my Attack on Titan shirt on. All right, so that, because I'm gonna go attack Titans. Okay, I think I'm ready. Everyone else ready? We're ready to get into this. Because I'm pretty friggin' upset. You ready to hear from Upset Sparrow? I'm ready. Okay. Hey, Kieran on YouTube, let's go. All right. I'm gonna try and treat this as if I'm making a video because I am gonna turn this into a video, so I might pause and restate things that I'm saying. But let me get my lighting looking just a little better here. All right. I think that's all right. Here. I'm gonna look in the camera. What's up, Prosium? Thanks for dropping in, man. On the X side, I really appreciate that. Yeah, anybody on the X side can just chat. I can see it on YouTube. You can chat. I can see it. You guys can chat pretty much everywhere. I'm going to kind of get through a few things, and block things off in chunks, and then interact with chat. So if you drop in a chat, um, and I don't seem to be responding, it's not because I'm ignoring you. It's because I'm just trying to stay focused on a topic, kind of get through a few things, and then interact with chat. And I want to turn this into a video. Um, yeah, there you go. M1 DNAM, what's up on YouTube? Hello, good to see you. Thanks for popping in. All right. Thanks everybody for jumping on and watching yet another one of my rants. I have become extremely frustrated making these videos. I'm honestly sick of making videos and streams based on this topic, which is essentially that I think the tech industry as a whole has become a steaming pile of junk. And we all just seem to be okay with it. And I use that word, we all, in a generalized sense. I understand that there are plenty of people who would disagree with that take and would say, no, no, I do care, and so on and so forth. And that's great. But not enough people care. So I want to be clear about something. The point of these videos where I go on these rants and discuss these topics is not for me to be purely negative and offer no solutions. What I'm really trying to do is shed some light on current practices that are happening, the status quo of the tech industry, and help other programmers who are watching this either now live or in video format later to see that there are problems and to help them understand that these problems don't have to exist. We actually have a lot more going for us than we think we do. Unfortunately, we seem to be led by people who are completely blind to the idea that we can do a lot better. And that blindness might come because of a number of different reasons. Usually it's monetary, usually it's financial rewards that push someone to turn a blind eye towards a problem that they're perpetuating. But there could be a bunch of other reasons for it, including reasons which are not, what would you say? Including reasons which are not, oh man. Okay, yeah. Including reasons which are not malevolent. For example, it could just be pure ignorance, which is a completely understandable thing. If you want to talk about people being ignorant, all you have to do is look right here. Watch some of my streams where I'm building a video game on the browser, and you can see a lot of my ignorance just shine through like a bright light in the middle of the night. However, my problem is that we have too much of whatever reason you want to pick for why the tech industry is in such a bad shape. And so what I'm going to do is I'm going to continue a series of videos that I've already continued, or I've already started, sorry, I've already been through, where I cover specific topics that go into more nitty-gritty details, things that programmers would benefit from understanding as to why things are, in my opinion, such a bad shape. So again, to make this clear, the point is to empower programmers who are watching this now, whether you're back-end, front-end, embedded, in AI, whatever it is, wherever you are. I want you to be aware of the issues that we're facing and that they have real-world impact. I need to preface this by stating that I have already gone through academic and scientific studies that demonstrate statistically that we are bleeding money. In terms of the tech industry, we're creating vastly more bloat than we ever have before. We're overutilizing or misutilizing, if you want, our hardware capabilities to degrees we've never seen before. And there are real world impacts to people's lives, including loss of life. I've already been through this before. I'm going to take some time over the next week or two to structure these videos into something that's a bit more sensible to follow, because right now it's just on my YouTube lives and it can be all over the place to kind of pick them apart. It's hard to find. So that's on me. I'm going to make it my responsibility now to start structuring these videos so that I can always reference a particular video and go, here's some data that shows this. Even if you don't find the data compelling about what these impacts are, you have to admit that a vast majority of the world, or at the very least a decent portion of it, runs on some kind of technology, and that technology requires some kind of software to run. And it doesn't matter what the software is, there is code that is executing a thing. It is beneficial to everyone, and you can internalize the argument. You can say it is beneficial to you, to your family, to your kids, to your grandparents, to your siblings, etc., etc. There is a benefit. whether it's about happiness or enjoyment in life or an actual life or death situation. Software and hardware is not something to just be kind of dismissed when there are problems with. Operating rooms rely on this, 911 call centers rely on this, fire departments rely on this. We have a heavy reliance on these things, and it is incumbent on, unfortunately, it is a responsibility incumbent on programmers like you and I to ensure that we're doing the best that we can, because it's really, really easy to look at something you're dealing with right here and now and go, this isn't really a problem. Like what's a few seconds in terms of performance right now? The users won't care. But you have no idea what that impact is going to be down the road to someone you care about who might lose their life because of decisions that we collectively make together when we dismiss these problems away or kick the can down the road. This is very real, and I have been through this before. So just in terms of data alone, there's evidence to support that we're doing massive amounts of harm to the entire world. And even if you don't want to look at that, I'm stating it again. This has an impact on you. Your life and the lives of people you care about is impacted. So this is not just people standing up on a high horse, like me standing up on my high horse and being all righteous about like whether you should be doing programming this way or that way, and gatekeeping and all that stuff. That's not really what's going on here. What's really going on here is that I really care about this field, like a lot. It has given me, a high school dropout who lived in his car, slept on park benches, had to be self-taught, couldn't make it past grade 11 because of home circumstances. This industry has given me a way where right now, at the ripe old age of 40, I get to take care of a family of my own, and I care about them deeply. And to some degree, as much as it is possible, I care about everybody that I'm looking at behind this camera right now. This stuff means something to me. And if you really care about this stuff, you should really care about the nitty-gritty details and how the little things can make huge impacts. So that's what I'm trying to bring awareness to. And as frustrating as it is to continue making these videos, I think it's important to cover these topics. Okay. So the first thing we're gonna do, I'm gonna switch over to a different mode. Hello everyone in chat, everybody who's jumped in. I really appreciate you guys jumping in. Let me do this. Sorry, folks. This is what today's stream is going to be like. I'm going to try and structure this as well as I can. Okay. Prosium on X. I've said this take before, and you may have seen it, but I'll reiterate here so you can yoink it for video content if you wish. Okay, fair enough, Pros. I believe the solution to this problem is to produce content that counters the clean code books of the world. It's critical to have new engineers first contact be with sensible ideas implemented well. It isn't enough to just say X is bad or to give high-minded reasons why they're bad. What is necessary is to show a better path and teach it in an accessible way. TLDR, we need educators and educational materials. Okay. To that end, Pros, that is exactly right. And I don't just agree with you. I've been trying to live that. So if you just give me just a second, I'll show you what I've been trying to do. And so I will yoink this for video content. Okay, so just one sec. All right, let me switch over. And I'm gonna use this for video content right now. All right. As I'm making this video, Pros on X, Prosium on X, made a compelling point. The point being that it's not enough for me to just make videos and live streams about this and say things are bad. The point, the thing that programmers need to understand is why things are bad and then how to make things better. That is the reason why I'm building this game that I've put up on screen now. It may look like a just like a whatever stupid, it doesn't matter game. It's just some dude building a game, and to some degree, yeah. But this is the educational content that I wish I had. Okay, and so what I'm trying to do is offset the short videos and clips that I am creating about rants about the state of the tech industry with long-term multiple videos about how I would kind of build something today at an extreme level, like the polar opposite of what's happening in the tech industry. So I'm going to give just a brief overview of how I'm building my game and why. So I'm about to get into a rant about the state of the tech industry yet again. We're going to go over some videos and articles, and we're going to cover this. But just to be clear, I don't just say X is bad. I also try to show a different way to implement X. And I want you to all, anybody who's watching this at any point, I want you all to remember that I am not of any particular caliber above you. There's nothing about me that makes me a better human than you, or more intelligent than you, or in any way more special than you. I'm a high school dropout. I was homeless. I was and continue to be a complete moron. I make mistakes all the time. Ask just about anybody in my life and they will agree with that. I will agree with that. I'll be first in line to agree with that. And yet, when I push myself to when I push myself quite a bit, I can accomplish quite a lot, which means you can too. The reason I say that is not to toot my own horn and go, look at how great I am. The reason is because if I am not of any particular special uniqueness above you, then there's no reason why you couldn't do similar things. So the game here, okay, I'm building it in C. So far, I have not used any structs or pointers, although I am using some structs now because I went down into the nitty-gritty with chat as to whether flat arrays, which is what I've been using, versus structs have any amount of performance impact at all. But you can go back. I've been building this for about a year and some months with everybody who's been watching. It's just straight up C, vanilla, no standard library, flat arrays. I compile that to WebAssembly. So I have a compiler over here, WASM32. And then, let me go back to the game. Then I run it on the browser. The browser acts as a client. The WebAssembly acts as a server. So imagine that WebAssembly is strictly an input-output machine of numbers, and it just manages the game state. My rendering mechanism is the browser. That's my client. So the client could be anything. It could be a desktop application. It could be a terminal. It could be whatever you want. And for my client, in this case the browser, I'm using vanilla CSS. I'm using vanilla JavaScript. And I'm embedding the WebAssembly into the HTML. And I'm embedding all my assets into the HTML when I do the compilation step, which means that in order to ship this game, all I have to do is ship one single HTML file and you get to run the entire game. On top of that, I'm pushing the boundaries of rendering. I'm not using Canvas. I'm not using WebGL. I'm not using WebGPU. There's no hardware acceleration at all. It's just div elements. That's it. Because the DOM is not slow. You just have to be careful how you use it. And you can be. It's not beyond your ability to do that without some complicated framework, which we're going to get into later in this stream. It's part of the reason why I'm so upset right now. But you can even see we have 3D. You want to know what runs as 3D? CSS, vanilla CSS. That's it. Okay, so that's why I'm building this game on streams, because I want this to be the educational portion where you get to see someone push the boundaries. What can you do with extremely little, and what can someone like me pull off without having to kind of appeal to authority and use a gigantic framework or a big piece of software or whatever it is. Okay, so thank you, Prosium, for bringing that out. That's important. All right. So, hang on. Okay. Let me go back to here. So, what we're going to cover today, we're going to cover the recent news about AI inside of NVIDIA's essentially graphics cards, more or less, DLSS4. We're going to cover that a little bit. We're going to look at a new Threat Interactive video where they go over how really performant video game rendering was done on essentially potato hardware, what we would consider potato hardware today. We're going to look at that as a counterexample to the AI stuff. And then I'm going to bring that into a very deep dive into some of the insanity that surrounds React and implementations of front end web with crazy, React paradigms. And when I talk about these topics, you could replace React with any other framework you want, any other library you want, whether it's Vue or Svelte or Rust or Zig or whatever it is, and ask the same questions that I'm kind of attacking today. Does the thing I'm using fit into the paradigm that is being attacked on my stream, is being ranted about on my stream? Why might this be bad? And maybe I should be asking the question of, can I do this better? The can I do this better portion, like I said, is a part of why I'm building the video game that I am. And you can catch all the live streams. They're all free on my YouTube. They go all the way back. I go through Zig, Odin, and then to see all on the browser. So if you want to if you want to watch someone do like a completely different way, a completely different take on how to do massively, interactive things that come with video game rendering, complex server side things that come with like managing states and whatnot on the server, things like that. Those are all topics we touch on a lot in very deep detail in on my stream. So that's one way you can get some of the counterbalance points out of that. Okay. All right. So the first thing we're going to do is we're going to watch this video on how NVIDIA added AI to DLSS4 and what that means. This is going to give us kind of a groundwork overview on uh, um, how this has been implemented, and then we're going to get into how this relates to everything else that I'm talking about. It's only 6 minutes, so it's not so bad. I'm going to make sure I have everything set up for this. Browser. I'm going to run a test. Okay, I'm going to play this for a second and check the volume levels. Could I just trouble somebody to make sure that they heard that? Loud? Should it be a little bit lower? I'll turn it down a little. Maybe a little more.
AI is changing everything about
How's that? Volume loud, yeah. Upscaling tech hasn't, yeah. Yeah, Prosium. Half of that maybe? Okay, let me turn it down a bit more then. You know what? Here's what I'll do. I'll also go like this.
about how we work and play, and computer graphics is
that a
no
bit better?
exception.
It's crazy loud. Yeah, I apologize.
We've been reinventing computer graphics with artificial intelligence since the launch of RTX in 2018. DLSS is
Yeah, good. Perfect. All right. Okay. We'll just, awesome. Thank you, folks. I appreciate the help. All right. We're going to watch this from the start. We're going to get an idea of what this is, how it works. Then we're going to jump into the Thread Interactive video and another video, and then we'll just go from there. All right.
AI is changing everything about how we work and play, and computer graphics is no exception. We've been reinventing computer graphics with artificial intelligence since the launch of RTX in 2018. DLSS is always learning. To improve the AI powering DLSS, we analyze image quality and fine-tune our training datasets and algorithms. Then we retrain the model to make it smarter, faster, and easier to integrate. DLSS is the best way to play. Today, we are introducing the biggest advancements to DLSS since 2020, including new multi-frame generation for RTX 50 series GPUs, enhanced frame generation for RTX 40 and 50 series users with faster performance and lower memory usage, and a new model powering ray reconstruction, super resolution, and deep learning anti-aliasing that enhances image quality and stability for all GeForce RTX users. Alongside the RTX 40 series in 2022, we launched Frame Generation, where an AI network used an optical flow field along with motion vectors from game geometry to generate a single frame between every pair of traditionally rendered frames. The Blackwell architecture is built for neural rendering, and that unlocks new AI capabilities for DLSS. We can now generate multiple frames per traditionally rendered frame. To make this possible, our research team developed a new AI model that generates the optical flow field more efficiently and more accurately in order to generate multiple frames. Multi-frame generation requires consistent and precise frame pacing. DLSS 3 frame pacing had variability because of how different game engines divided workloads between the CPU and GPU. With the Blackwell architecture, the display engine was improved to leverage flip metering when generating multiple frames, ensuring that the GPU delivers consistent and optimal frame pacing. Additionally, 5th generation Tensor cores on RTX 50 series GPUs have the computational horsepower necessary to quickly execute the series of AI models. These software and hardware innovations enable DLSS 4 on RTX 50 series GPUs to generate up to 3 additional frames between traditionally rendered frames. This brings revolutionary performance versus traditional native rendering. Most frame generation games available today can easily be updated to enable multi-frame generation with the NVIDIA app. In the NVIDIA app driver settings menu, open the DLSS override and select your desired output mode in the frame generation drop-down menu. When RTX 50 series graphics cards hit store shelves, multi-frame generation will be supported in more than 75 games and apps. In addition to multi-frame generation, our team has also been hard at work developing foundational improvements for our existing DLSS technologies.
Today, we're introducing an enhanced single-frame generation model for RTX 40 and 50 series GPUs, which, like the multi-frame generation technique for Blackwell, uses 2 AI models, one for optical flow and another for frame generation. The result is increased performance and lower VRAM usage, as you can see here. DLSS 4 also introduces a more powerful transformer-based model for super-resolution ray reconstruction and DLAA, using 4x more tensor core processing power to reconstruct images at even better image quality for all RTX owners. Previously, all these technologies used a convolutional neural network model, also known as CNN. CNNs were the dominant architecture for image-related applications during the early years of deep learning development. A CNN processes pixel information through local operations, spatially around a small number of neighboring pixels, and temporally across multiple frames. Now we're introducing a new transformer-based architecture for the first time. The transformer architecture is driving the scaling laws of artificial intelligence, and it's what powers the recent advancement in AI applications. Compared to the CNN models, transformers use self-attention and can much more easily identify the longer range patterns across a much larger pixel window. Transformers scale much more effectively than CNNs, so our transformer models ingest over 2 times more parameters and requires 4 times more compute during inference. In fact, DLSS 4 on RTX GPUs is the first time transformer models generate sequential images at a high real-time frame rate. Blackwell's Tensor Cores provides additional hardware acceleration that boosts the inference speed of these transformer models even further. When using DLSS Super Resolution, the end product of the transformer model is more temporally stable with more image detail in motion. In intensive ray trace content, the transformer model for ray reconstruction gets an even bigger uplift in general quality, especially for scenes with challenging lighting. All the common artifacts from typical denoisers are significantly reduced. With the NVIDIA app, GeForce RTX users can optionally update their DLSS games with the transformer model of ray reconstruction, super resolution, or DLAA. In addition to games, DLSS 4 is coming to multiple creative apps, including Unreal Engine 5, D5 Render, and Chaos Vantage. DLSS significantly enhances the real-time viewport experience, multiplying the frame rate in D5 Render, enabling designers to better iterate and collaborate on their work. Neo-rendering is creating increasingly more on-screen content, and these generated pixels are higher quality than what's output by traditional native rendering. With super resolution or ray reconstruction alone, 3 out of every 4 pixels are generated with AI. When adding frame generation, 7 out of 8 pixels are generated by AI. Finally, with the DLSS 4 multi-frame generation, 15 out of every 16 pixels are generated by AI.
With the RTX 50 series and DLSS 4, we've introduced a new generation of neural graphics, so games are more beautiful, run faster, and are more responsive. The AI-powered future is here, and DLSS 4 is the best way to play.
Okay. All right. That sounds great, right? Sounds great. Yeah. The general idea is games cannot run at frame rates that are nice and juicy, you know, when you're playing the game. Well, we have a solution for that. We have AI. And what AI will do, as you just saw, is it will kind of figure out between each frame or even between pixels in the same frame, things that need to get filled in as you're rendering real frames, which is frames that are coming in from the video game engine or the video game itself, and frames that the AI can then generate in between, so that it gives you that sense of, hey, there's a higher frame rate and the game feels more buttery. You know, there's more going on. It's a better experience, right? Can you think of any possible problems with this? Like, just take a minute and just see if you can think of any possible problems. And there are definitely a few technical ones that you can come up with for sure, right? DLSS 4 is the best way to introduce massive input latency and make your esport title feel like dog crap, right? Right. I mean, it's not hard to come up with reasons why this wouldn't be a good thing. Input latency is one. Having AI incorrectly determine whether a particular frame needs to be rendered or not in between, like generating a bad frame. Yeah, fake frame generation, that's right. And so it feels off. Adding in artifacts, which you can't control. The AI just chooses that something should be rendered here, and there are artifacts of it. You might even get like fuzzier or fuzzier resolutions or fuzzier aspects of the game. Or there we go. Prosium is exactly right. It's artifacting. Generating 3 frames from 1 means 3 times more artifacts. You guys are saying as I'm saying it. How about this? What if you have a portion of the game that is actually really optimized in terms of rendering, and the AI decides this isn't optimized, or the AI inserts more frames and it de-optimizes, or it devalues the optimization that you've made for a given portion of the game. Right? So these are all problems. Now, that's fine, because a response could be, well, you could have 2 responses ultimately. So one response could be, yeah, but think about how much better games are going to be, right? So games are going to generally, this is an improvement. And the second response is, it will continue to improve. So just because things are bad now and AI is bad now, it will get better, which means that the current state is not the end state. So complaining about the current state is fine up to a certain point, but you're excluding the possibility that this will get so good that it won't matter in the end. Perhaps. However, that requires me to believe something that is future. What that means, that argument is based on something that I cannot actually turn into reality, because I have no idea whether AI is actually going to improve to the point where these problems are solved. And even if they are, I have no idea if the improvement of AI will actually introduce new problems. So what you're asking me to do in a very religious manner is have faith in the future of AI. However, I would counter with this. I have some evidence that you can base in reality, historical evidence of why this is bad. Hey Ray on YouTube, game devs have dual 4090 PCs with i9 still manage to make boring games. I mean, that's the other thing, right? Is regardless of the improvements that are being made in AI, what are the state of games that we're making right now? I don't think generally gamers are happy. And say what you will about gamers not being happy and spoiled little brats and whatever, but it generally still holds true. And DLLS, the developer probably needs to opt in, so an optimized game can just say no to it. I actually don't think so. Let's say that that's true. All I see is a period on X. Let's say that that's true. Let's say that you can just opt in. The other problem that needs to change is you have to have enough movement from programmers in general in the industry not opting into it, so that the financial incentives to not opt into it are also removed, or reconstructed. So for example, you might not want to opt in to AI generated frame rates. However, you might not really have a choice if you want that sweet funding, because that VC guy has been told that AI generated frames is the way to go. Right? And we don't have enough people who say no to this in terms of like the people in front of the computer writing the code. And that's one of the reasons why I'm doing streams like this, is because I would like more people to be more aware of the issues that surround this kind of junk. Crysis released in November 13, 2007, by the way, so this historical trend is strongly backed by data. Right. And so that's the counterpoint here. The counterpoint is what you're asking people to do is have faith in a future, and the error bar. So if you think about like here, we'll try this. If you think about how the future goes, right? What's going to happen? Geez, it's hard to get it, but it's gonna kind of look like this, right? It's gonna look like a less than sign, right? Because what happens is you start off here, and then the error bar increases as you go into the future in terms of your predictive ability, right? Because, geez, like, who can predict the future to a high degree of quality? You can't. But if you go the other direction and you look back on what has been and how things have played out, especially if you break things down into their principal arguments, there's plenty of historical data. One thing that we know to be true is that when you create abstractions and you make it easy for people to do more with quote unquote less, or an easy button that lets them do things like render more frames or write that complicated user interface for a website, or not have to worry about memory management in their favorite server side language. When you do these things, people often opt to take the easy road way more than they should. And it's not because the easy road is bad. Okay, it's not like when you find an easy solution to a problem, you shouldn't do it, but just because it's easy. But you psychologically just go, I don't want to ask questions about this. That's what happens. The thing has been solved. I don't need to worry about this. That's way easier on my brain. I'm just going to go with it. I'm not even going to ask why this thing is here. This AI-powered frame generation thing is just one example of many that opens up that door for people to go, I don't need to ask questions about why, I just need to do. And that is a very bad place to be. One of the things that this causes, so this will be the next video we look at, is essentially the death of people having the capability to understand what's going on beneath all of these layers of abstractions. And so because we talked about NVIDIA and DLSS, we're going to look at this video here. I'm going to switch over now, and then we're going to look at the Thread Interactive video. Okay. Okay. So essentially the short version of this is that I'll play this a little bit faster so we don't do a full, we don't do a full 14 minutes here, because that is a bit long. But essentially what the argument here is, when these things are introduced into the ecosystem, it essentially kills the ability for people, it neuters the ability for people who create the things that you enjoy using from optimizing them, which means that you reverse course from optimization and you go full speed ahead on bloat and crap. Okay, so we're going to have a look at this one.
Official PC specification requirements for Monster Hunter Wilds, a game that is highly anticipated by many gamers. I wanted to show you guys this screenshot so you can see just what's wrong with games that are being released on the PC today. I'll give you a moment.
Do you see that? Yeah, this game is another medium graphics setting. I mean, like...
Yup, in order to play this game at 1080p with medium settings, with what I'd call is 1080p appropriate hardware now, you're expected to utilize frame generation. If that doesn't scream lazy or incompetent optimization to you, then I don't know what will. My fear is that this will become the norm and, as a result, kill proper optimization altogether. We'll be discussing this trend in today's video, but before we get into that, a quick word from our video sponsor. This video is brought to you by MSI and their DataMag 20GB/s magnetic portable SSD. If you're looking for fast, reliable storage on the go, this SSD has got you covered. With read speeds up to 1600 MB/s and write speeds up to 1500 MB/s, it's perfect for handling large files, video editing, RAWs, and high-res photography. Plus, its super speed USB 20GB/s interface means no more waiting around for file transfers. The DataMag also boasts a sleek, durable aluminum casing for top-tier heat dissipation, while weighing just 81 grams. You can take it anywhere, and what's really cool is a magnetic metal ring that lets you snap the SSD directly onto your smartphone. With capacities up to 4 TB, you'll have more than enough storage for work, play, or travel. Best of all, it's fully compatible with iPhones, Android devices, Windows PCs, Macs, and even gaming consoles. It's plug and play with USB-C, or you can use the included USB-C to A adapter for instant connectivity. Personally, I've used this drive to transfer game files and recorded footage between my systems, and it's been a game changer. So whether you're capturing ProRes footage on the go or just need reliable storage for everyday use, MSI's DataMag magnetic portable SSD has got you covered. Check out the link in the description to learn more. Hey, what is going on, guys? Danny here. Welcome back to the channel, and I hope you've all been doing well. Today's topic is something I've been wanting to cover for a while now. As someone who's been gaming on the PC for a long time, I've witnessed the evolution of games, hardware, and technologies. However, we're currently in a troubling era where developers are relying too much on upscaling and frame generation technologies to meet performance targets rather than optimize their games properly. I wanted to start this discussion off by reading a quote from a TechSpot article citing NVIDIA CEO Jensen Huang. He mentions how we can't do computer graphics anymore without artificial intelligence. He said, "We compute one pixel, we infer the other two." I mean, it's incredible. And so we hallucinate, if you will, the other 32. And it looks temporally stable. It looks photorealistic, and the image quality is incredible. The performance is incredible.
I just want to leave it here for a second. I just want you to read that sentence a few times, or this paragraph. And I would argue that you could you can make replacements here, and the argument will hold true. We can't do HTML anymore without React. We can't do HTML anymore without Svelte or Vue. We can't do CSS without Tailwind. We can't do memory safety without Rust. I mean, you name it, right? But that is an incredibly wild thing to say.
Now, upon reading that, your first impression might be, so what? What's the big deal if he said that? Actually, that's exactly what you'd expect him to say. His company designs and manufactures hardware along with developing software that utilizes AI. It's in NVIDIA's best interest to push AI-driven technologies like DLSS and frame generation. This fits right into their business model. Sell powerful hardware that leverages AI software to make games run faster. But here's the thing, by saying something along those lines, he's promoting more than just his company. He's encouraging game developers to lean into AI technologies to achieve performance gains instead of focusing on optimizing their games properly. And you have this sense of urgency for that targeted audience where if they're not on board with this, they risk being left behind. So that's where I have an issue with this. Now, let's talk about the crux of this issue. Modern game developers are relying on technologies like NVIDIA DLSS and AMD FSR along with frame generation to meet performance goals instead of making sure their games run well on a wide variety of hardware. And it's not just a few developers, it's becoming an industry-wide trend. Take Monster Hunter Wilds as an example, which I mentioned earlier. For a game that targets 1080p medium settings, the system requirements recommend you enable frame generation to get a smooth experience. That's just bullshit, dude. Frame generation by its very nature doesn't improve actual in-game performance. It just interpolates frames to make things seem smoother. It should not be called a performance booster, it's actually a frame smoothing technology. You still have to deal with the same underlying performance issues. I'm not saying frame generation is inherently bad. In fact, it's a fascinating technology, and when used correctly, it can enhance the gaming experience. But it should be an optional feature for gamers with high-end hardware, not a requirement for playing a game at mid-range settings. This just feels like a lazy way for developers to avoid optimizing their games for a broader range of hardware. Furthermore, when it comes to frame generation, a lot of people seem misinformed, thinking that you can turn it on at any state and smooth out your performance. Here's the thing, while it may appear smoother, I found the input lag becomes absolutely atrocious at lower frame rates, and I recommend that frame generation should only be used if you have a minimum of 60 FPS average. So if you're struggling to run a game and it's running at like 30 FPS, sure, it might look smoother with frame generation. It might look like it's running at 60 FPS, but the input lag will be very noticeable. The other thing is that it's funny how they mention frame generation with medium settings and you have graphics cards like a 2070 in there, which doesn't even support frame generation unless it's using FSR. Let's look at another example, Star Wars Outlaws. This is a game that many were excited about, and it's one of the first open world games set in a Star Wars universe. Sounds great, right? Well, if you're planning to play this game on PC, you better have DLSS or FSR enabled, because regardless, if you're trying to play the game at high settings or with minimum settings, 1080p or 4K, they're recommending you to use upscaling. Like, I'm surprised to see how at the enthusiast level, they're recommending owners of a 4070 or 6800 XT to use upscaling at 1440p high preset, when the game looks like this. Now, it's not horrible, and in some instances it looks good, but it's not what I'd call mind-blowing or a level of visual fidelity that we haven't seen before. The same goes for Monster Hunter Wilds. Like, this isn't a game that looks earth-shattering or anything, and yet it demands frame generation at 1080p medium. What a joke. Here's a clip of a channel called Zeoworms Gaming showing Horizon Forbidden West at 1440p, max settings with DLAA, so that's not upscaling, running over 60 FPS on a 4070, and visual fidelity-wise, they don't look worlds apart if you ask me. So according to the specs that Ubisoft have listed for Outlaws, that just shows a sign of poor optimization, plain and simple. Another game that I was anticipating myself was Test Drive Unlimited Solar Crown. I remember playing Test Drive Unlimited 2 on the 360 and having loads of fun with it. Imagine the derailment to my excitement when I saw the PC requirements. Yet another game that requires users to enable upscaling to hit what should be standard frame rates at moderate resolutions. Like a 2080 now is what I'd call a 1080p card. I've said that last year as well, it's an entry-level card at this point, but it's definitely not a 620p card. Yup, they recommend you should use balanced at 1080p. Me personally, I would never go below quality when it comes to upscaling presets, even at 4K, and at that point I'd be lowering other settings. But 1080p balance looks noticeably blurry. And what I find comical about all this is that we're talking about a racing game that doesn't even look that much better, if at all, compared to Forza Horizon 5, which was released in 2021, and that was a game that ran like a total dream. These developers should be embarrassed. This trend of pushing upscaling and frame generation as a crutch for bad optimization is alarming, especially for PC gamers who have invested in high-end hardware. So the question arises then, what the hell happened to proper optimization? Back in the day, we didn't have these kinds of technologies, and developers had to make sure their games ran well on hardware available at the time. Let's take a trip down memory lane. Remember when Crysis came out in 2007? Yes, it did become a meme for being the benchmark of PC performance. At every chance, you had gamers going, can it run Crysis? But the game was also optimized to the best of the developer's ability for the hardware available back then. Sure, you needed a beast of a machine to max it out, but even mid-range PCs could run it at playable settings without the need for fancy upscaling tech. I remember on my first rig, which had an NVIDIA 8800 GT, which wasn't anything crazy at the time, and I was able to get a playable experience using a mixture of medium and high settings. Now, I understand that games have become much more complex, with larger worlds, more detailed textures, and more advanced lighting techniques like path tracing. Take a game like Black Myth Wukong, for example. I've been playing this game quite a bit lately, and this is a game with a level of visual fidelity that I said, okay, this actually looks next gen, and I totally get why you'd need upscaling or frame generation to enjoy the eye candy, with our current hardware that is. But as you guys saw, that's not always the case. An example that I'm reminded from last year was Remnant 2, a game that doesn't even have ray tracing and could pass off as a game from 2016 in my opinion. But the developers were basically telling players to turn on DLSS. Regardless, that doesn't mean developers should take shortcuts. Proper optimization means making sure your game runs well across a variety of hardware, not just recommending that players enable DLSS or FSR as a band-aid solution. I remember back in 2018 when NVIDIA had first introduced DLSS and real-time ray tracing in games, a lot of their demonstrations showcased the two enabled together. They showcased how demanding ray tracing was, but players could use something like DLSS to compensate for performance loss. A similar tone was set for frame generation when that was introduced, and there were showcases of it being used in Cyberpunk with path tracing, which is really demanding, and also Spider-Man Remastered with ray tracing. So in scenarios like those where a highly demanding but substantial visual graphics setting is enabled, that is where frame generation and upscaling make sense. But as we're seeing now, that doesn't appear to be the baseline anymore, and we're gradually dropping our standards. In fact, there's an argument to be made that developers are taking advantage of technologies like DLSS and frame generation to justify releasing games in a less than optimized state. Why bother spending extra time and money optimizing your game for PC when you can just tell your players to enable upscaling to get better performance? Another issue with this reliance on upscaling and frame generation is that it can fundamentally change your gaming experience. Sure, you can get a higher frame rate with these technologies, but the quality of the image suffers. DLSS and FSR aren't perfect, and there's often a noticeable drop in sharpness or clarity. Along with that, artifacting can be introduced when these technologies are used. This is highly dependent on what resolution you're targeting and what preset you use. Like I said earlier, me personally, I find that the quality preset at 1440p or 4K is just as good as native in most cases. Some gamers might not mind this trade-off, especially if they're playing fast-paced games where frame rate does matter more than visual fidelity. But for games that rely on immersion and detail like RPGs or open world games, Black Myth Wukong was an example that I used, this can detract from the overall experience. And let's not forget that not everyone has access to hardware that supports these features. Older GPUs, or even some mid-range ones, might not be able to utilize DLSS or frame generation, leaving those gamers stuck with subpar performance. So
The last 2 or 3 minutes of this argument is so prescient to web development as well. Why would you want to optimize particular aspects of your website when you can just dump React in, and fine, it comes at the cost of some load time maybe, or a more bloated set of bandwidth, or more memory usage, but at the very least we've shipped something faster and we got something out the door and you can use it. Except for exactly his point, not everyone has the ability to run the bloat that you're pushing out. And what you're doing is you're excluding by necessity an undeterminate amount of potential consumers or users who might otherwise use what you're doing if you just spent a little bit more time optimizing and not being this lazy. It's exactly the same argument.
where does this leave us in the long run? Well, if this trend continues, we could see a future where developers stop optimizing their games for PC entirely. Instead, they'll just rely on AI-driven technologies to fill in the gaps. This could lead to a fragmented experience where only players with the latest and greatest hardware get to experience smooth FPS, while everyone else is forced to compromise. What's worse is that this approach could widen the gap between PC and console gaming. One of the reasons why many people choose to game on PC is because of the flexibility it offers. You can tweak settings to get the best performance and visual fidelity for your specific hardware, but if developers stop optimizing their games properly, that flexibility could disappear. We might end up with games that just run poorly on high-end PCs as they do on consoles, with no way to improve performance except by using upscaling tech and frame gen. Also, what happens when developers start baking in these technologies into games and then there's really no way to disable them? This could definitely lock out players on older hardware that doesn't support the tech, or it could severely tank performance. What happens when developers start catering to one vendor's tech over the other? AMD said that for RDNA 4, they're going to be rolling out a new form of FSR that relies on AI. So while that does mean benefits to performance, image quality, and stability, this does allude to hardware exclusivity. RDNA 3 or RDNA 2 based cards won't be able to utilize it, which is fine. I mean, we have that now where RTX 30 series can't use frame generation in games, but the 40 series can. But like I was saying, what happens when frame gen is baked in at a lower level in the code where you just can't disable it from the settings menu or a config file? What happens when a game only supports NVIDIA RTX with their baked in technologies? Oh, well, you have a Radeon card? That sucks. Better switch to Team Green if you want to enjoy this game. Imagine a world where we actually start to see hardware exclusive games on the PC. You know what? Actually, don't imagine that. I'm sure nobody wants that to come to fruition. So to wrap it up, while technologies like DLSS, FSR, and frame generation are impressive and can enhance the gaming experience in certain situations, they should never be used as a substitute for proper optimization. Game developers need to stop relying relying on these technologies as a crutch and start putting in the effort to make sure their games run well across a wide range of hardware. PC gamers, especially those who invest in high-end components, deserve better. We shouldn't have to rely on AI-driven upscaling just to hit playable frame rates at standard resolutions and settings. If this trend continues, we might even see a decline of proper PC game optimization altogether, or the disappearance of it, and that's something that none of us want. But I'm curious to hear your thoughts on the matter. Have you noticed this trend of poor optimization in recent games? Are you okay with developers relying on upscaling technologies, or do you think they should be doing more to optimize their games on PC? As for now, that's going to do it for this one, and we'll be touching base in the next video.
Okay. These arguments around video games, which I obviously agree with, they exactly map on to web development. So the idea here is that AI gets so good at generating frames for a video game that video game programmers or producers no longer have to worry about the optimizations of the things that they're generating for a game. They don't have to worry about certain elements that are that can be admittedly frustrating or difficult to deal with. All they have to do now is rely on AI to optimize a way for them. Unfortunately, that comes with the cost of, well, now you have to run particular hardware that runs these things, and if you don't, tough luck. And when something actually hits the wall, you're not going to actually be able to optimize it in the way that we used to optimize it, which is get down into the core of things, pop that hood, and change the programming so that it's more optimized to meet the necessity of the player. Instead, we just give it away. We give all that responsibility away and go, consequences later, people will still pay us. It's exactly the same thing with web development. What happens is that something like React or similar things, or like Rust and similar things, come along and go, you don't have to worry about these things. You don't even have to understand them anymore. We've solved them for you. So go ahead and use this thing, and you can just ship out whatever you're going to ship out, and it doesn't matter anymore about, the finer details are kind of like obfuscated away to the point where you don't have to worry about them. This is a bad trend, because what it does, again, it neuters the ability for people to actually focus on true and proper optimizations in their place. What you're going to do is you're going to find out that less and less people have the capability to actually optimize these things away. Even if you can make the argument that you don't need to optimize everything under the sun, which I would agree with, what you're going to do is when you really need that optimization, nobody's going to be around anymore, because everybody is trained in these paradigms where you are not just told that you don't need, you're not encouraged to think about what you might want to do to optimize this better. You're actually discouraged from it, and it has a cost, not just in our world as programmers, but it has an actual cost to the people who use these things. And you know that it's true, because if you can make the argument that people who play games are going to suffer a cost for the way that these games are built, or the way that these websites are built, or the way that these languages work, or whatever, then you can also make the case that the people who use this kind of software and this kind of hardware out in the world, doing things that we just trust to be safe all the time, they are also going to suffer. There is a huge downwind consequence of this. It is a necessary entailment of all this crap, that it's going to just crapify everything else in our life that we just take for granted right now as safe and good and completely usable. This is a bad way, a bad path for us to follow. Hey NumPy, how you doing? Hey Ghost, good to see you. Thanks for the lurk, Prior. I appreciate it, NumPy. Okay, so the next thing I'm going to do thank you for the follow, NumPy. I appreciate it. Okay. So now you might be wondering this. Well, it's really, really hard to get properly optimized games out the door today. Going back to my argument previously, what you're asking everybody to do is to have faith that AI will continue to get better, and it will present no further issues. It will not create any further issues. And like I said, as you do that, your error bar, as you go further into the future, your error bar of good quality predictions increases. So essentially, I have to take it on faith that things are going to get better. However, we have historical data, which proves that the way things are today is not the way things have to be. We have a an overwhelming, almost unfathomable amount of optimizations available at our fingertips. We could have video games that are doing absolutely mind-blowing things with zero AI at all. Would it take more effort? Yes. But would people open their wallets a lot more for video games like that? 100%. And the same thing goes with web development, and the same thing goes with server development, and the same thing goes with all these other crazy things that happen in the software world. We have way more capability than we think we do. Again, this is why I'm doing videos like this, because I want programmers out there to understand how bad things are and how much space, how much room there is to make things better. So what we're going to do is we're going to go over this video from Thread Interactive. This will be the last video on the video game portion of things. And then we're going to get into some nitty gritty about React. All right. So just a sec, folks. Make sure to say hi, or feel free to drop messages in chat. You know, I'll try and keep an eye on it. What's up, Shreyas? Yeah, you know Thread Interactive? Yeah, NumPy. Yeah. They're pretty good, man. Okay, here we go. All right, I'm ready. Okay, so we're going to play this. We're going to play it in normal mode because I want to play it a little bit faster because it is 16 minutes. However, they talk pretty fast. They go through the data pretty fast. So let's take it normal mode, and we're going to step through this. And we're gonna look at a historical example of how optimizations were done in the past and how much you can push things that from a historical perspective in terms of optimizations.
At most for a native 1080p 60 FPS target on a desktop 3060. A traversal competent open world with dense and optimized foliage, interactive non-screen space global illumination, and dynamic light compatible shader illusions that provide nanite levels of detail for a fraction of Nanite's cost, and without the under-discussed visual problems Nanite promotes. Gamers and developers, hit that subscribe button before I get started on providing you with exclusive performance statistics that measure out the how and why this game is so performant, and what technical decisions provide the realism this game offers. Followed by a conclusion segment where I'll explain where our 9th generation target hardware can build upon the scenario to enhance where realistic presentation is lacking. The reason why I'll be doing such a deep technical analysis of Days Gone is because I want more people talking about it. Successful games like Red Dead Redemption 2 and Witcher 3 get plenty of spotlight in day-to-day conversations, media, and content creators because those games did very well in sales. That causes a perpetual culture that thrives but is meaningless in lessons that need to be learned. Days Gone didn't do nearly as well, which means it barely comes up in conversations. Media and content creators don't feel like it's popular enough to draw in ad views or reference immediate topics.
You can see this in web as well. There's the same mindset, which is that the most successful thing gets the most attention, and just because something, well, what that means is that essentially when something is less successful for whatever reason or less popular, it gets less attention. And what you do is you remove the ability to look at positives or negatives of the thing that was less successful. So I really appreciate this take because he's going into something that had not as much accolades and not as much financial success, but proves a point in a positive or negative direction.
Even the director pointed out Sony's neglect to showcase the IP they own. So enough is enough. We're producing this video to achieve that mentality shift the industry is needing right now. Now, Days Gone uses Unreal Engine 4.11. But Bend Studios did a lot of modifications which I'll show in great detail to get this title looking as complete as it does. With the following settings I consider optimized, combined with a full system restart before opening the game, it uses at most 67% of our desktop 12GB 3060 for a 1080p 60fps target, and the median millisecond budget is at most 8.9 milliseconds. Meaning we have about 7 milliseconds worth of budgeting to enhance what is most definitely lacking in this overall impressive presentation. That's not including where even greater performance potential could be obtained, which I'll explain as we analyze the frame. So here's the captured frame, and as you can see there's tons of foliage because that's the main thing I wanted to stress test in this video. Subsurface scattering is very nice to look at when you're in contrasting lighting environments. For the capture, I wanted to include very little sky since it's usually pretty cheap to render. For instance, when I tilt the camera up to the sky, I gain about 4 milliseconds, so we have a good worst case scenario here. Now this frame is in motion, and the motion blur in this game is not very strong, but the TAA is a whole other story, and it's very poor in my opinion. Now, funny thing, the person who worked on this TAA was an ex-NVIDIA graphics programmer, and this TAA has a striking resemblance to the DLAA. This TAA ghosts less than DLAA, but when completely still, both resolve to what I would say in a uniquely clear, super sampled-like image. But the moment any motion is introduced, walking, idle animations, or subtle camera swaying, you get a very specific image blur from both techniques. Geometric edges also share a similar appearance and behavior. It's possible the developers of DLAA/DLSS reference an old colleague's TAA work for DLSS 2 and beyond. But moving on, let's start analyzing this game's graphics pipeline. Now the first thing that I notice in this pipeline is the small presence of dispatches in this area. I haven't seen such a clean frame startup since our Need for Speed analysis. But unlike Need for Speed, it begins a prepass which only renders the scene depth. This is done because depth is cheaper to render and allows the GPU to prevent wasting performance on more complicated/expensive pixel shading that could appear behind closer geometry. I'm not a huge fan of prepass rendering because you still deal with single pixel overdraw in terms of pixel rejection, and it also goes against an optimization rule regarding resource context, which can end up doubling the cost of any inherent optimization issues. Take the foliage and landscape for example. Very few resources are taken for the landscape, but it acts as a major occluder. Well, look how much more GPU resources the foliage invokes on the GPU. What blew up this timing was mostly this context that the GPU processed, but that context was only used to get depth values. Now in the second geometry pass, your GPU has to spend the same amount of time processing the same context to write or process different information that it could have processed beforehand. This is a generalized hierarchy of rendering scenarios from the best to worst performance potential. Now, if it wasn't for what I'll show you happens after the pre-pass, I would have guessed this game was forward rendered. Because forward rendering, at least in UE5 to 5.3, can only handle a few shadow map casting lights. Forward Unreal games have a heavy reliance on baked or screen space shadows, which only need that scene depth, which is very similar to Days Gone. That's why this particular area in the game looks very flat and dated. The over-reliance on screen space shadows feels more than odd, as if there's some kind of unique limitation for shadow maps other than the low cost they would normally have in a standard optimized deferred or forward plus rendering pipeline. Also, Epic Games added Bend Studios screen space shadows in Unreal.14, which also introduced a new forward shading pipeline. But Days Gone's second geometry pass doesn't look anything like UE4.14's forward base pass, which doesn't support moving sun shadows, and it definitely doesn't resemble UE4.11's deferred pipeline. As you can see, the amount of render targets is way smaller, but the most shocking difference is the absence of the albedo render target. Now it could be compressed in a way where we can't perceive it. For instance, there's no world normal render target either, but you can modify the color histogram of these render targets, and you'll be able to pick out some hints of some normal-like information, but only for a few objects. We could end up with an update from Bend Studios after this video is released. If we do, you'll be able to find those in our pinned comments, which also correct video errors and commonly asked questions. In a couple moments, I'll show a later stage in the pipeline that codes some of these render targets into more traditional G-buffer representations. Now we're not done discussing the second geometry pass. This render target contains depth information relating to geometric microdetail, allowing screen space effects such as SSAO or screen space shadows to fake incredible amounts of detail for a relatively cheap price. Actually, according to the lead rendering programmer Graham Aldridge, this depth illusion is said to have no noticeable performance impact. Because it's texture and bitmap based, it provides very stable imagery at grazing angles. With TAA removed, the only major instabilities you'll see here are from screen space effects like shadows or AO that are expecting TAA smoothing, but the ground material itself is still pretty stable without any help. Modern graphic trends would have this detail geometrically displaced with something like Nanite, which can introduce geometric aliasing or tie your shadow techniques to expensive VSMs or noisy megalights. Because the pre-pass provides the final scene depth, the first half of the second geometry pass only writes static objects, saving pixel invocations from randomly writing to a velocity buffer that could be contextually worthless from draw to draw. When it starts drawing objects with velocity, a render target with only 2 channels is written into. The next part of the pipeline processes a temporal disocclusion update, as well as integrating the micro detail inside one of the render targets into a depth scene copy. Occlusion culling is done next for about 300 different draws. Next, some decal buffers are written along with some Atlas texture updates. The high Z is processed, and then this buffer has information from the current frame's render targets gradually decoded into its various channels. You'll find a lower precision depth scene without the micro detail, and some other G buffers. Some noise-like textures and dense geometry are processed, followed by the production of this texture, which contains altered half-resolution depth data. Reading the full resolution depth scene with a micro detail impression, screen space shadows are then gradually processed in 3 draws. Despite the screen space shadow technique being the exact same shader used on Unreal, it's far less dependent on temporal smearing in Days Gone's unknown configuration. But there are scenarios where it needs alteration for TAA independency. We have too many people who act like fixing smear dependency harms optimized performance. This is a very poor and commonly spread take that this channel is constantly proving against. CryEngine also has a very fast screen space shadows that resolve much more stable without any anti-aliasing. And even if it was, say, 33% more expensive to resolve independently of TAA, that's where our stated target hardware can easily and should progress in. If you agree with that philosophy, hitting the subscribe button gives industry support for that view. 600 draws are written to the sun's cascaded shadow maps, with each cascade being a squared resolution of 1152 pixels. The shadows are then downscaled to a more advanced encoding to around 1/10 of its original size. I haven't looked into the purpose of this texture yet, but it could be used for soft shadows or light culling. Then sprites containing depth and other information of foliage are rendered on these textures. Now this is super interesting because the Pine Tree meshes in Silent Hill 2 Remake caused horrible performance problems and further hurt performance when they were drawn directly into the shadow maps. Here in Days Gone, there's a whole other highly optimized approach for foliage shadow casting. This resource is updated slightly, followed by major changes to these environment textures which represent sky and terrain information, which are most likely used as specular fallback when screen space reflections aren't available. Because Days Gone is a use case game, a mostly static environment with dynamic lights, small-scale lighting hints based on static geometry are placed throughout the world. So the GPU during this stage cross-references the dynamic shadow map information to provide local bounce light based on the direct lighting. By toggling crouch to move this character's shadow on this red car, we can see how reactive this non-screen space bound GI is. It's not updating on a per frame basis. It spaces out some of the update computations across a few frames to save performance without the player noticing too much. The GPU is just using a shadow map information to determine if that local lighting hint near the car is within the sun's direct lighting. Now, does this technique provide radiance-based lighting or indirect shadows? No. But it only costs 0.6 milliseconds versus Lumen's best case scenario 5 milliseconds in open worlds, and it doesn't come with Lumen's temporal smearing issues either. Taking a look at some other scenes in the game, it's more than possible that it's being combined with a variant of DFAO. There's a lot of potential in scaling a system like this, and I bet there's plenty of developers who are stuck with UE5 who'd rather take a system closer to this one that takes a computational advantage of their static environment. And then similar to Days Gone's approach, have it combined with maybe radiance-based SGI, or sparse ray tracing support for dynamic elements. Something that's in that 2 millisecond range that supports indirect shadows. But no one's funding the research for an approach like this for the common use case game. The next step in the pipeline uses one of the full resolution render targets, depth scene, and half resolution lit buffer of the previous frame to produce the current frame's screen space indirect lighting texture here. It's then spatially denoised and blended with the previous frame's indirect lighting buffer. This is similar to Jedi Survivor's approach to temporal and direct lighting, except done about 4 times faster with a lot less channel ghosting. But it also fizzles more. This happens when temporal logic is less accumulatory, but it also means that it's less prone to motion smearing. The GPU then evaluates what objects are in direct lighting and where subsurface scattering needs representation. The previously lit buffer is overwritten across multiple draws to complete the direct and indirect lighting, only taking these textures as the input. MIP change and translucence are processed, followed by the addition of fog. Color grading, UI updates, and motion blur are processed. The UI is added in the same draw that adds TAA to the frame. Here's the estimated millisecond budget for this capture scenario, which is within the median millisecond budget. Now let's start going over the conclusions and related lessons for this title. Number 1, I'd reference this game's take on foliage appearance. It feels like too many games get foliage incorrect, and this game is just using a 6-year-old subsurface scattering model to achieve its incredible results. Also note how close foliage uses more vertices to fit tighter around the alpha mask, but further foliage uses less vertices for a less precise fit. The more precise cutout prevents pixel overdraw better, and since only so many objects can logically appear closer to the camera, you'll have guaranteed limits of vertex processing. But logically, you're going to have more foliage pushed away from the camera, which can easily multiply the cost of those high vertex representations into a vertex bottleneck that will combine with inherent quad overdraw issues you encounter with distant meshes. This outlines an approach for foliage LODs, and it shows the need for software rasterization, as seen in Nanite, that exclusively runs on quad-unfriendly, distant foliage. Number 2, take note on how the warm color grading makes a huge difference in conveying the sun's indirect lighting influence. Number 3, Days Gone uses temporal noise in order dithering. With or without TAA, the order dithering pattern has a more subtle fade, but the order dithering in this game is slightly jittered. At a VSync 60 FPS, we can easily perceive some flickering because the jitter pattern has more than 2 consecutive movement positions. If engines keep order dither jitter under 2 alternating positions, the eyes at 60 Hz will be able to blend the 2 frames together without needing TAA. Yup, that's right. That means forcing a dependency on 59 frames or higher per second. With the context of knowing our target hardware, visual and performance goals, forcing a dependency on something that looks and feels good is far better than forcing a dependency on something that looks like crap. Another key observation: it doesn't fade between the full order dithering pattern. Order dithering in Days Gone blends between numerical checkpoints within the order dithering algorithm where noticeable patterns aren't as present. Number 4, learn from this game and add a depth of field toggle to your gameplay, since many have a strong dislike for the effect. And do not tie graphics functionality such as the user interface or graphic stability in effects like screen space shadows, SSR, soft cascaded shadows, or SSGI to blurry TA. All these effects can include their own temporal accumulation without destroying performance. Number 5, you can now reference the indirect lighting approach in this game. While not perfect, it's clear that approaches can be built upon this with ray tracing or radiance-based GI. Speaking of ray tracing, I do think this game runs well enough to support ray trace reflections, which could help significantly with specular leaking in this game. Moving to APIs like DirectX 12 or Vulkan can make that easier, and if used properly can provide more performance headroom via async compute support. Number 6, don't underestimate how important shadows can be. Unreal is one of the few engines where lights do not support shadow fadeouts, as light sources become more distant from the camera. It's only recently that one of our brilliant members of our Threat Interactive Discord drafted a pull request for Unreal source code to support this exact functionality. Shadow casting and light overlap are far bigger performance killers, but Unreal just fades lights away because that's what works for Fortnite. Number 7, you can now reference a stellar example.
I just want you to hear that again.
Fades lights away because that's what works for Fortnite. Are far bigger performance killers, but Unreal just fades lights away because that's what works for Fortnite. Are far bigger performance killers, but Unreal just fades lights away because that's what works for Fortnite. Are far bigger performance killers, but Unreal just fades lights away because that's what works for Fortnite. Are far bigger performance killers, but Unreal just fades lights away because that's what works for Fortnite. Number 7, you can now reference a stellar example of geometric management, but Days Gone does have low resolution texture issues, and it's probably because it was developed before 9th Gen came out, so this is something that new productions and new hardware can easily improve on. There are more areas to discuss the improvements on, but I and thousands of others don't believe that poor performing alternatives being pushed today are the right approaches. I would love to provide shader code and workflow tips for the related graphic approaches such as the depth illusion or Unreal Material functions that provide the order dithering approach I discussed. I want to see these in other projects, including my own game, but there's not a lot of code resources to share at the moment. I analyzed that need for speed title because I wanted to showcase the modified screen space reflections because this studio and our X amount of subscribers believes that the way that it looks and performs should be adopted as industry standard. But it's not, and so aren't these geometric workflows. Instead, poor TAA is. I'm not sure if this is obvious, but my plan for Threat Interactive is to start dispersing Unreal Material templates and resources that align with the topics we present in videos like this one. We want to bring awareness to developments such as engine patches, which could end up being more economic in terms of project integration than a full-fledged fork, and developments such as the new SMA plugin, which still needs some work but is a good step in the right direction. If you've developed shaders, patches, or Unreal code that relates to fixing the issues we speak about, contact us with your innovations because we might be able to push your important developments out to the industry with our videos. If you enjoyed this video or learned something new, all I ask for is a like and subscribe. The subscriber number has the power to change the entire industry because it helps us reach more people, including gamers, developers, and even companies who want to get involved in producing more optimized and better looking games. It represents an ignored market that includes developers who want better performance in visuals without Vaseline-like or noisy image quality. And if you really want to catapult the success of this channel, we need more people to post our videos in giant game subreddits, forums, and huge game-related Discord channels. This pushes our reach by the hundreds of thousands, and a big thank you to those who have done just that. I do see you sharing and it means a lot. If you're new to the channel, watch every single video we've done in order of release to learn the truth about modern optimization. Until then, Thank you for watching this one.
Okay, so real talk. Drop in chat the percentage of things that were talked about in this video that you understood. While I set up here for the next. Number of percentage of understandability. Yeah, 69, yeah. Yeah, 50. Yeah. Hang on. I gotta make sure I do this right. Okay. Okay, I think I'm good. All right. So that video by Thread Interactive, even if you didn't understand, a decent portion of it, and admittedly, there are a lot of things that I had to look up when I first watched that video, and I still don't understand all of it. However, there were at least two things that stood out to me. One, the reliance on something that has been built for your convenience without thought to the consequence of what that is. And that video pointed out that there are consequences. For example, unexplored territories, where the convenience of something, which comes at a cost of having that convenience, leaves or excludes the possibility of looking at something that could be better, even if it might be more challenging to accomplish. You don't even look at that possibility when you have these conveniences available to you. The other thing that the video did really well is it outlined positives and negatives of the way that the game was rendered. Some things were positive, some things were negative. Some of the lighting, some of the distance on foliage, with vertices counts and rendering, things like this. He went over the fact that there was plenty of room for improvement, and that's on older games with older engines on older hardware. We have a lot more by comparison today. Maybe not by some magically distorted massive jump, but it's definitely better. The engines I think that we use today for video games most people would admit have improved to some degree or another. Hardware has improved to some degree or another. We have not gone backwards, we've gone forwards. Have these games made equivalent improvements in terms of their visuals, in terms of even things like simple things like gameplay mechanics or capabilities, in terms of utilizing the hardware they run on properly? No, they have not. Most, if not all, have not. It is exactly the same problem that we see in software and in web development. Things get better, the things we produce get worse. And the reason is because you rely on things getting better as a crutch. It is a convenience mechanism so that you can do less. Turn off your brain, don't ask questions. And the fact of the matter is that these things are not as complicated as they seem. You might look at a video like that gets into really nerdy, nitty-gritty details about the specific elements of how things are rendered, how many passes it takes to render something like a shadow or fogs or like a fog in the game or things like this. You might consider the same kind of you might consider some things in web development as similarly unapproachable, like imagine trying to do vanilla CSS for a large project, or rendering your DOM state when you have dynamic UI elements. Things like this seem complicated and out of reach, especially when you include the fact that you see a lot of people who have solved these problems using things that are also themselves complicated. They're complicated solutions to these problems that already seem complicated, and you go, well, I'm not crazy. These things are complicated, right? How am I supposed to do it? You can. These things are not as unapproachable as you think. That's the point that I'm trying to make here. We do have the ability to solve these things, and it leads to positive outcomes, such as if you're in it for money, you're going to make more money because you produce something that's better. If you're in it for quality, you're going to produce something that's better quality. If you're in it for learning, even if you just want to try and tackle these problems so that you can learn how to tackle those problems when they appear again, that's also a positive, even if they don't have a direct, to production result. That at the very least, it's something that helps you to discern better how you might solve that problem or related problems in the future. There's almost no reason why you should look at issues that we're facing in the industry and go, I don't want to learn this thing. I would rather lean on what other people are telling me to do, or what I'm inundated or bombarded with. I need to reach for the solution in order to figure something out. It's simply not true. And if there are plenty of people who are just like you who do it all the time, which means you can do it too. And we need a lot more of that. Now, I'm going to take a second and I'm going to bring up some React content. And we're going to go over how the same kind of principles and thinking have affected web development with React. And it's going to be nitty-gritty. Hello, everyone who's watching right now. I appreciate all the viewers. Okay. All right. So yesterday, I had Jay Larky on, Jay Larky from X. I believe he goes by Parasocial Fix on other platforms. And we talked about how frameworks like React, we primarily talked about React, but similar frameworks, have caused a problem in the web development space that is akin to the problem that we just went over in the video game development space, which is a bunch of conveniences are set up for you such that you solve problems within the paradigms of that convenience. You no longer solve problems that exist outside of the convenience simply because you do not know how to. And it was quite eye-opening to hear Jay Larky say that he is shocked, if I remember this correctly, hopefully I get it word for word just about, but he is shocked by how many React developers do not know how to write HTML or something along those lines, which is a shocking statement to make, because what is React if not built upon the foundations of HTML, JavaScript, CSS? So the idea that you don't know these things as a React developer is like, you failed. The entire enterprise has failed at that point. So we're going to read this article. I pulled it up. Thanks, Justin, on YouTube. I'll make sure I'm set up here. Okay, I'm ready to go. You know what? I'm going to do one quick thing here. Mark my words, by 2026, React will be utilizing AI in its core to write web user interfaces. I'd put money on it. All right. Web crap has taken control. We're going to read this puppy, and then we're going to do a deep dive into a lot of stuff that's going on here. So it's going to be one of those streams, boys. It's going to be one of those streams. Okay. I just want to start with, you can take a lot of the arguments that are being presented here and you can replace it with just about anything you use. This could include HTMX, for example. Like, just, it could be Svelte, it could be Vue, it could be Zig, it could be like anything, right? So think about it from the argument, from the principled argument standpoints. React is, in my opinion, the worst offender of these arguments. And so it's an easy one to pick on, even though, you know, it has its place and it has things that are positive about it. But when you look at what it does and the consequences of what it does, it's a very easy one to pick on and extract the negative outcomes of it, right? And that might be a bit unfair to React, but unfortunately, it's the truth, and life isn't always fair. So I don't really care for that argument. I'm just going to be as honest as I can be. Any application that can be written in JavaScript will eventually be written in JavaScript. It's no secret that web development has been problematic for a long time. Year after year, more tools are created with the pretense of being the ultimate solution to fix all web crapware once and for all. But are they accomplishing anything? I wonder if I have, I don't think I have dark mode here. Okay, doesn't matter. So in 1990, HTML was invented. In 1994, CSS was invented to fix HTML. In 1995, JS was invented to fix HTML and CSS. In 2000, XHTML was invented to fix HTML. In 2006, jQuery was invented to fix JavaScript. In 2010, AngularJS was invented to fix jQuery. In 2013, React was invented to fix AngularJS. In 2012, TypeScript was invented to fix JavaScript. In 2014, Vue was invented to fix React and Angular. In 2016, Angular 2 was invented to fix AngularJS and React. In 2019, Svelte 3 was invented to fix React, Angular, and Vue. In 2019, React hooks were invented to fix React. In 2020, Vue 3 was invented to fix React hooks. In 2020 also, Solid was invented to fix React, Angular, Svelte, and Vue. In 2020, HTMX1 was invented to fix React, Angular, Svelte, Vue, Solid. 2021, React Suspense was invented to fix React. Again, in 2023, Svelte Runes was invented to fix Svelte. And in 2024, HTML is still used on 100% of websites. And this is from a Fireship video, well, inspired by Fireship video. In 2016, Jose Aguanagua published on Hacker Noon a brilliant and hilarious article about an anecdotal conversation between two web developers, one who hadn't touched web code for some years and the other who was still working in the field. Even after 8 years, it still holds up pretty well, except for the ending where the author clearly underestimated how far the tentacles of the web would go. I'm just going to move back to the back end. I just can't handle these many changes in versions and additions and compilers and transpilers. The JavaScript community is insane if it thinks anyone can keep up with this. So this is the article, How It Feels to Learn JavaScript in 2016. Okay. And it's a back and forth. Okay, between two developers. No JavaScript frameworks were created during the writing of this article. Okay. Hey, I got this new web project, but to be honest, I haven't coded much web in a few years and I've heard the landscape changed a bit. You're the most up-to-date web dev around here, right? Second person. The actual term is front-end engineer, but yeah, I'm the right guy. I do web in 2016. Visualizations, music players, flying drones that play football, you name it. I just came back from JSConf and ReactConf, so I know the latest technologies to create web apps. Cool. I need to create a web page that displays the latest activity from the users. So I just need to get the data from the REST endpoint and display it in some sort of filterable table and update it if anything changes in the server. I was thinking maybe using jQuery to fetch and display the data. Oh my God, no one uses jQuery anymore. You should try learning React. It's 2016. Oh, okay. What's React? It's a super cool library made by some guys at Facebook. It really brings control and performance to your application by allowing you to handle any view changes very easily. Oh, that sounds neat. Can I use React to display data from the server? Yes, but first you need to add React and React DOM as a library in your web page. Wait, why 2 libraries? Okay, so one is the actual library, and the second one is for manipulating the DOM, which now you can describe in JSX. JSX, what is JSX? JSX is just a JavaScript syntax extension that looks pretty much like XML. It's kind of another way to describe the DOM. Think of it as a better HTML. What's wrong with HTML? It's 2016. No one codes HTML directly anymore. Right. Anyway, if I add these 2 libraries, then I can use React? Not quite. You need to add Babel. Anybody remember Babel? And then you're able to use React. Another library? What's Babel? Oh, Babel is a transpiler that allows you to target specific versions of JavaScript while you code in any version of JavaScript. You don't have to include Babel to use React.js, but unless you do, you're stuck with using ES5. And let's be real, it's 2016. You should be coding in ES 2016 plus like the rest of the cool kids too. ES5? ES 2016? I'm getting lost here. What's ES5 and ES 2016 plus? ES5 stands for ECMA Script 5. It's the edition that has the most people target since it has been implemented by most browsers nowadays. ECMA script? Yeah, you know, the scripting standard JavaScript was based on in 1999 after its initial release in 1995. Back then when JavaScript was named LiveScript and only ran in the Netscape Navigator. That was very messy back then, but thankfully now things are very clear and we have like 7 editions of this implementation. 7 editions for real. And ES5 and ES 2016 are the 5th and 7th edition respectively. Wait, what happened to the 6th? Oh, you mean ES6? Yeah, I mean each edition is a superset of the previous one, so if you're using ES 2016 plus, you're using all of the features of the previous versions. Okay, and why use 2016 plus over ES6 then? Well, you could use ES6, but to use cool features like async and await, you need to use 2016 plus. Otherwise, you're stuck with ES6 generators with coroutines to block asynchronous calls for a proper control flow. I have no idea what you just said, and all these names are confusing. Look, I'm just loading a bunch of data from a server. I used to be able to just include jQuery from a CDN and just get the data with AJAX calls. Why can't I just do that? It's 2016, man. No one uses jQuery anymore. It ends up in a bunch of spaghetti code. Everyone knows that. Right. So my alternative is to load 3 libraries to fetch data and display an HTML table. Well, you include those 3 libraries, but you bundle them up with a module manager to load only 1 file. I see. And what's a module manager? The definition depends on the environment. But in the web, we usually mean anything that supports AMD or CommonJS modules. Okay, and AMD and CommonJS are definitions. These are ways to describe how multiple JavaScript libraries and classes should interact. You know, exports and requires. You can write multiple JavaScript files defining the AMD or CommonJS API, and you can use something like Browserify to bundle them up. Okay, that makes sense, I think. What's Browserify? It's a tool that allows you to bundle CommonJS described dependencies to files that can be run in the browser. It was created because most people publish those dependencies in the NPM registry. What's an NPM registry? It's a very big public repository where smart people put code and dependencies as modules. Like a CDN? No, not really. It's more like a centralized database where anyone can publish and download libraries so you can use them locally for development and then upload them to a CDN if you want to. Oh, like Bower. Yeah, but it's 2016 now. No one uses Bower anymore. Oh, I see. So I need to download the libraries from NPM then. Yeah, so for instance, if you want to use React, you download the React module and import it into your code. You can do that for almost every popular JavaScript library. Oh, like Angular. Angular is 2015, man. But yeah, Angular would be there. Alongside Vue or RxJS or other cool 2016 libraries. You want to learn about those? Let's just stick with React. I'm already learning too many things. If I need to use React, I fetch it from this NPM and then use this Browserify thing? Yes. That seems really complicated to grab a bunch of dependencies and tie them together. It is. That's why you use a task manager like Grunt or Gulp or Broccoli to automate running Browserify. Heck, you can even use Mimosa. Grunt? Gulp? Broccoli? Mimosa? What the heck are we talking about now? Task managers, bro. But they're not cool anymore. We used them in like 2015. Then we used Makefiles, but now we wrap everything with Webpack. Wait, Makefiles? I thought that was mostly on C or C++ projects. Yeah, but apparently in the web, we love making things complicated and then going back to the basics. We do that every year, so just wait for it. We're going to do assembly in the web in a year or two. Okay, you mentioned something called Webpack. It's another module manager for the browser while being kind of a task runner as well. It's like a better version of Browserify. Okay, why is it better? Well, maybe not better. It's just more opinionated on how your dependencies should be tied. Webpack allows you to use different module managers and not only CommonJS ones. So, for instance, native ES6 supported modules. Okay, I'm extremely confused by this whole CommonJS ES6 thing. Everyone is, bro, but you shouldn't care anymore with System.js. Jesus Christ, was another noun.js. Okay, what is System.js? Well, unlike Browserify and Webpack 1.x, System.js is a dynamic module loader that allows you to tie multiple modules in multiple files instead of bundling them in one big file. Wait, I thought we wanted to build our libraries in one big file and load that. Yes, but because HTTP2 is coming now, multiple HTTP requests are actually better. Wait, can't we just add the 3 original libraries for React? No, not really. I mean, like you could add them as external scripts from a CDN, but you would still need to include Babel then. Okay, and that's bad? Yes, you would be including the entire Babel core. It wouldn't be efficient on production. On production, you need to perform a series of pre-tasks to get your project ready that make the ritual to summon Satan look like a boiled eggs recipe. You need to minify assets, uglify them, inline CSS above the fold, defer scripts, as well as, hang on, I got it. So if you wouldn't include the libraries directly in a CDN, how would you do it? I would transpile it from TypeScript using a Webpack plus System.js plus Babel combo. TypeScript. I thought we were coding in JavaScript. TypeScript is JavaScript, bro. Or better put, a superset of JavaScript. More specifically, JavaScript on version ES6. You know, the 6th version we talked about before. I thought ES 2016 Plus was already a superset of ES6. Why do we need this thing called TypeScript? Oh, because it allows us to use JavaScript as a typed language, bro, and reduce runtime errors, bro. It's 2016. You should be adding some types to your JavaScript code, bro. And TypeScript obviously does that. Flow as well, although it only checks for typing, while TypeScript is a superset of JavaScript which needs to be compiled. And Flow is? It's a static type checker made by some guys at Facebook. They coded it in OCaml because functional programming is awesome, bro. OCaml? Functional programming? Yeah, it's what the cool kids use nowadays, bro. You know, 2016, functional programming, high order functions, currying, pure functions. I have no idea what you just said. No one does at the beginning, bro. Look, You just need to know that functional programming is better than OOP, bro, and that's what we should be using in 2016, bro. Wait, I learned OOP in college. I thought that was good. So was Java before being bought by Oracle. I mean, OOP was good back in the days and it still has its uses today, but now everyone is realizing modifying states is equivalent to kicking babies, bro. So now everyone is moving to immutable objects, bro, and functional programming, bro. Ask-Elm guys had been calling it for years, bro. And don't get me started with Elm guys, bro. But luckily in the web now we have libraries like Ramda, bro, that allows us to use functional programming in plain JavaScript, bro. Okay, are you just dropping names for the sake of it? What the hell is Ramda? No. Ramda. Like Lambda, bro. You know, the David Chambers library? David who? David Chambers, cool guy, plays a mean coop game, one of the contributors for Ramda. You should also check Eric Meyer if you're serious about learning functional programming, bro. And Eric Meyer is functional programming guy as well. Awesome guy. He has a bunch of presentations where he trashes Agile while using this weird colored shirt. You should also check out some of the stuff from TJ, Josh Canis, Sindra Sorhas, Paul Irish, Adios Manny. Okay, I'm going to stop you there. This is all good and fine, but I think it's just so complicated and unnecessary for just fetching data and displaying it. I'm just going to go back to the beginning of this conversation. He asked, hey, I have this new web project. It's a page that displays the latest activity from the users, so I just need to get the data from the REST endpoint and display it in some sort of filterable table and update it if anything changes in the server. And we're at functional programming, bro. I'm pretty sure I don't need to know these people or learn all these things to create a table with dynamic data. Let's get back to React. How can I fetch the data from the server with React? Well, you don't fetch the data with React. You just display the data with React, bro. Okay, what do you mean fetch the data? You use fetch to fetch the data from the server, bro. Hang on, you use fetch to fetch the data? Like, who's naming these things? I know, right? Fetch is the name of the native implementation for performing XML HTTP request against a server, bro. Okay, so it's AJAX. No. AJAX is just the use of XML HTTP requests. But sure, fetch allows you to do AJAX based in promises, which then you can resolve to avoid callback hell. Callback hell? Yeah, every time you perform an asynchronous request against the server, you need to wait for its response, bro. Which then makes you add a function within a function, which is called the callback pyramid from hell, bro. Okay. Okay, and this promise thing solves it? Yeah, by manipulating your callbacks through promises, you can write easier to understand code, bro. Mock and test them, as well as perform simultaneous requests at once and wait until all of them are loaded, bro. And that can be done with fetch. Yeah, bro, but only if your user uses an evergreen browser, bro. Otherwise, you need to include a fetch polyfill, bro, or use request, Bluebird, or Axios. God, anyone remember Axios? How many libraries do I need to know, for God's sake? How many of them are there? It's JavaScript, bro. There has to be thousands of libraries that all do the same thing. We know libraries. In fact, we have the best libraries. Our libraries are huge, and sometimes we include pictures of Guy Fieri in them. Did you just say Guy Fieri? Okay, let's get this over with. What's Bluebird, Request, and Axios? They're libraries to perform XML HTTP requests that return promises. Didn't jQuery's AJAX method start to return promises as well? We don't use the J word in 2016 anymore, bro. Okay, just use fetch and polyfill it when it's not in a browser, or use Bluebird, Request, or Axios instead. Then manage the promise with a wait within an async function, and boom, you have proper control flow. This is the third time you mention a wait, but I have no idea what it is. A wait allows you to block an asynchronous call, allowing you to have better control on when the data is being fetched and overall increasing code readability. It's awesome. You just need to make sure you add the stage 3 preset in Babel, or use syntax async functions and transform async to generator plugin. This is insane. No, Insane is the fact that you need to pre-compile TypeScript code and then transpile it with Babel to use await. Wait, it's not included in TypeScript? It does in the next version, but as of version 1.7, it only targets ES6. So if you want to use await in the browser, you first need to compile your TypeScript code targeting ES6 and then babble that up to target ES5. At this point, I don't know what to say. Look, it's easy, okay? Code everything in TypeScript, all modules that use fetch, compile them to ES6, which is really JavaScript version 6, transpile them with Babel on a stage 3 preset, and load them with System.js. If you don't have fetch, polyfill it, or use Bluebird, Request, or Axios, and handle all your promises with await. We have very different definitions of easy. So with that ritual, I finally fetched the data, and now I can display it with React, right? Is your application going to handle any state changes, bro? I don't think so. I just need to display the data. Thank God. Otherwise, I would have to explain Flux to you and implementations like Flummox, Alt, Fluxible. Although, to be honest, you should be using Redux. Okay, I'm just going to fly over the names. Again, I just need to display data. Oh, if you're just displaying the data, you didn't need React to begin with. You would have been fine with a templating engine. Are you kidding me? Do you think this is funny? Is that how you treat your loved ones? I was just explaining what you could use. Stop. Just stop. I mean, even if it's just using templating engine, I would still use TypeScript and System.js and Babel if I were you. I need to display data on a page, not perform Sub-Zero's original MK fatality. Just tell me what templating engine to use and I'll take it from there. There's a lot, bro. Which one are you familiar with, bro? I can't remember the name. It was a long time ago. JTemplates, JQuote, Pure. Doesn't ring a bell. Any others? Transparency, JS Render, Markup.js, Knockout.js. That one had two-way binding. Another one, Plate.js, jQuery, Temple, Handlebars. Some people still use it. Maybe. Are there similar ones to that? Mustache, Underscore. I think even Lodash has one, to be honest, but those are kind of 2014. Maybe it was newer. Jade? Dust? Nope. Dot? EJS? Nope. Nunchucks? ECT? Nope. No one likes CoffeeScript syntax anyway. Jade? Nope. You already said Jade. I meant Pug. I meant Jade. I mean, Jade is now Pug. No, I can't remember. Which one do you use? Probably just ES6 native template strings. Let me guess. That requires ES6. Correct. Which, depending on the browser, needs Babel. Correct. Which, if I want to include without adding the entire core library, I need to load it as a module from npm. Correct. Which requires Browserify or Webpack or most likely that other thing called System.js. Correct. Which, unless it's Webpack, it should be managed by a task runner. Correct. But since I should be using functional programming and type languages, I first need to pre-compile TypeScript or add this flow thingy. Correct. And then send that to Babel if I want to use await. Correct. So I can then use fetch, promises, and control flow and all that magic. Don't forget to polyfill fetch if it's not supported. Safari still can't handle it, bro. You know, I think we're done here. Actually, I think I'm done. I'm done with the web. I'm done with JavaScript altogether. That's fine. In a few years, we're all going to be coding in Elm or WebAssembly. I'm just going to move back to the back end. I can't handle these changes in versions and additions and compilers and transpilers. The JavaScript community is insane if it thinks anyone can keep up with this. I hear you. You should try the Python community. Well, then, why? Ever heard of Python 3, bro? That is a banger conversation. From 2016. This thing was written in 2016. October 3rd, 2016. And it is still holds true today as it ever has. And they didn't even touch Tailwind. Are you really going to do vanilla CSS? You got to Tailwind it, bro. Okay, what's required for me to do Tailwind? Well, you need a precompiler. Okay, what's the precompiler? Well, whatever Tailwind includes as part of compiling your CSS. Okay, and so then what do I do? Well, then what you do is you write a bunch of classes and inlined into your class attribute in your HTML elements. Okay, I would have to do that anyway. What's the benefit here? Okay, well then what you have to do is you have to get Tailwind to read through all of your HTML elements and extract the classes that it's going to use. Okay, why would I do that? Because if you don't do that, then you might inadvertently include the entire Tailwind library, or in some cases, none of it, and then nothing will render. Okay, but wait, don't I have to add in classes into my style attribute on my HTML elements, whether I'm doing vanilla CSS or not? Yeah, but here's the benefit. When you use Tailwind and you pre-compile all the Tailwind attributes that you're using, it's going to generate a new CSS for you so that it contains only the attributes you want, and it will also uniformly allow you to use classes that are indicative of the thing you're using. So it's a very verbose way to style your HTML elements. Okay, but can't I also just write those uniform things myself? I can use IDs, which are technically supposed to be only used once per page, or I can use classes and mash the classes together so that I can create, a convention that I can repeatedly use. Why couldn't I just write my own utility library and create custom portions of my CSS to deal with custom things? Because you think about the maintainability. Why would you do that when you can just have Tailwind pre-compile an entire framework for you and then generate the CSS file that contains only the things you need? Okay, and I have to do that every time I make a change? Yeah. Okay, and where do I store the CSS files? Oh, the same place that you store the vanilla CSS files that you're going to create anyways. Okay, so I can create vanilla CSS files, but I have to forego that in favor of using a compilation build toolchain as part of Tailwind. Yeah, that's right. Okay, now what if I want to use another framework with it? Oh, well then things get a little bit more messy, because now what you have to do is you have to consider how you build Tailwind in addition with the other framework that you're using. So let's say it's React. Now what you have to do is you have to bundle in a compilation step for your Tailwind output along with your React output. I'm out. I'm out. Peace. Like it's crazy. It's absolutely insane. And I just did that one off the top of my head. Okay, we're going to keep reading. Hang on. I just gotta do something here. All right, there we go. Okay. That conversation pretty much mimics the my actual experience. Yeah, that's exactly right. It's exactly right, laugh. Yeah, there are things that you don't want to understand, right? Okay, so we read this part. Introducing React. After Facebook social media was released to the public, it soon became popular, grew in features, and turned into this very complex and slow application. To work around that, the people behind what is now called Meta decided to create a new JavaScript library called React, released to the public in 2013. Although many front-end frameworks are available today, the React ecosystem dominates the market, imposing all sorts of idiosyncrasies. Yeah, I'll zoom out a little bit here. So React, Node, jQuery, Angular, Express, ASP.NET Core, Vue, Next, ASP.NET, Spring Boot, WordPress, Flask, Django, Laravel, Angular, Fast API, Ruby on Rails, Svelte. I mean, these metrics might be a little bit different now since the creation of this article, which I think was 2014, or sorry, 2024. But yeah, okay, so 2023, it's probably a bit different now. React is the right solution for Facebook in the same way a hammer is the right tool to drive a screw. But worse than Facebook creating and using React is that soon after it was released, most tech companies around the globe started to believe they needed it in order to be as successful as Facebook. Life is not without irony now that Facebook's prestige has been fading away. One of the biggest changes introduced by React is that now everything should be asynchronous to avoid locking the UI when things get updated. So, if you want to change the state of something and check it later, you can't just simply do this. Variable equals test, if variable triple equals test, which is a hard equals, console log hello. To change the state of a variable in React, we need to call an asynchronous method. As a result, when the if statement checks for variable's value, there's no guarantee it has already been updated. The solution is to implement the useEffect callback and move the if statement into it like this. Import useState useEffect from React. Example equals variable set variable useState empty string. useEffect inner function set variable test, or set variable references here currently with an empty array at the end. Another useEffect with an inner function. If variable hard equals test console log hello, pass in variables of parameters that it is exposed to useEffect. Before you wonder, set variable will never return a promise or anything. So yes, you need a callback named useEffect, and it needs to have an array with the variables you want to handle. The problem here isn't limited to tripling the code and having a much more confusing syntax. It's the callback hell. It means that in practice, you can't debug your code anymore because the code flow is now super winding. It's not uncommon to see developers spreading things like console log past here all over the place. We have been working with UIs for over 50 years without needing to implement everything asynchronously by default. Only in specific cases where the application must perform a heavy operation in the background is the async approach useful to avoid locking the UI. In vanilla JavaScript, for example, methods like setTimeout, fetch, and even forAwaitOf are asynchronous, so the UI doesn't hang when they're called. Developers also have the option to make their own methods asynchronous. This approach offers a much easier and faster development process without sacrificing the user experience. But React is relentless in the shit business. For it, there's no such thing as static HTML. Literally, static HTML is the antithesis of everything that is React. React has no concept of static HTML. Every screen the user sees is the result of a JavaScript code, including React itself. Every screen the user sees is the result of a JavaScript code, including React itself, that generates the HTML either on the server side, SSR, or client side, CSR, with the latter being the default and therefore the most common. Most developers never heard about this concept until they realize their application is performing poorly, but then it's too late because migrating to SSR and React is a whole other nightmare. Even if you accomplish that, you're just shifting the inefficiency to the server, so global warming would still be looking at you. The user can check if the application is using CSR by requesting the browser to show the page source. If the content is just a template, it means the user machine is running JavaScript code to generate the HTML. Yes, folks, your battery life is most likely being compromised for no good reason. In React, you frequently have to deal with code in the middle of HTML, like React. Okay, let me read that again. In React, you frequently have to deal with code in the middle of HTML like React syntax. Here's an example. Is this, does anybody find this like actually like really readable? Like just out of curiosity, is there someone who's like, yeah, I can read like the whole thing's readable here, all good. Uh, yeah, I would be curious to see if anybody finds this more readable than a vanilla counterpart. How can someone call this mess progress? Back when there was no JavaScript framework, the code was separated in three types of files: HTML, CSS, and JavaScript. The separation was clear, and even if the developer wanted to embed everything into the HTML, they would have dedicated tags completely detached from each other. Not saying it was pure joy in a colorful dream, but clearly a much better solution than what these frameworks impose. But bear with me, because we're just scratching the surface. I have no idea what this does. Yeah, laugh. You were a fool? Yeah, exactly, Battle. What a fool. Sucker. I see dead packages. The JavaScript framework frenzy implies the applications will be developed with the help of third-party plugins, or as they call them, packages. Modern web developers are often so reliant on these packages that they forget the basics of math and algorithms. So, packages such as isOdd returns true if the given number is odd and is an integer that does not exceed the JavaScript maximum safe integer. I just wanted to pull this up. Yeah, I've seen isOdd before. And I've seen left pad before, but I'm pulling this up. String left pad. Literally just left pad a string. But in order to do it, you have to use, let me see. You have to use, there's a TypeScript definition, right? And then right? And check out the source for isOdd. Sure. Let's check out the source for isOdd. Let's go see what isOdd is doing. I think the article covers it too, but okay. So we've got an ESLinter for some reason. We've got npm-rc. We've got a Travis builder. We've got a generator for a README file, and then here we go. What is this? Well, it requires is number. And then you pass in a value, and then you do the absolute of the value. If it's not a number, it's not a number. If it's not an integer, it's not an integer. If it's not a safe integer, it exceeds the maximum safe. And then you do modulo 2 equals 1. That's it. They are frighteningly popular. It resembles factory workers on an assembly line. No clue on how to build the parts, only how to plug them. To make things worse, many old limitations of JavaScript can still be seen in its latest version. For example, when trying to parse JSON, if there's an invalid character, the language won't inform you the index, so chances are you won't be able to pinpoint the offending character, especially in long inputs. Let's add one more package to fix that, shall we? The list of annoyances is so long that Microsoft decided to create TypeScript, a language written on top of JavaScript to overcome some of its limitations. But because browsers don't understand TypeScript, your application needs a package to transpile it to JavaScript. And because JavaScript has to be compiled on the client side, it means the browser version may be incompatible with some recent JavaScript features, so another step is needed to transpile modern JavaScript to legacy to ensure old browsers will be able to run the application properly. As you can imagine, each iteration makes the code fatter. The result of this ever-growing inefficiency is that simple applications usually have thousands of direct dependencies plus thousands of indirect ones, resulting in insanely large JavaScript files. All of this usually sent to the client machine to be downloaded, parsed, compiled, and executed just to generate the HTML, which is what matters in the end. It's nuts. In some cases, all it takes is one of these unknown package developers to screw their code, causing countless applications around the world to fall apart. That's precisely what happened with LeftPad, as discussed in a previous article on how BS has dominated the tech industry. And I think a lot of us know about LeftPad, and we have been over some of the security issues that also come along with this, which I don't think is directly discussed here. Median page weight over time from Web Almanac. We've gone over this data on previous live streams. Kilobytes loaded by date. I mean, it almost doubles every 4 years. You would think, I agree with this comment, you would think that with the advances that we've made with libraries and frameworks and optimizations, that we would actually be having a far more steady, a bit more flatlined, or not so much of a dramatic increase. This is way too dramatic for people, when you hear people who say like things have never been better. When a web developer checks out their project and calls npm install or yarn install, oh boy, another package manager, or npx now, which is kind of like a superset of npm, or bun, now, it usually downloads a large amount of packages into node modules subfolder. The catch? These package major versions are hard-coded in the project's package JSON file. Handle it with care because it's all very fragile. This means all the pressure on users to have their systems up to date doesn't apply to the dependencies of web applications, unless developers manually check each dependency update every week, which is, of course, very unlikely. And since each dependency may also have its own dependencies, you may find inside the package folder another node modules subfolder, which can also have dependencies of its own, and so on. Depending on the order these things are loaded, you might end up with a broken project due to mixed versions of the same package running at the same time. So imagine you have a tree of dependencies. Your top level tree requires package A version 1 and package B version 2. Package B version 2 requires package D and E of some version. Package E, however, requires package A version 2, but your top level requires package A version 1. You might have a problem. Sure, there are packages to solve the problems with packages, and of course, they cause other problems that will require other packages. It's a recursive machine of chaos that literally makes a Hello World project require more than 40,000 files. They call this fun. But wait, because it gets worse. Since some dependencies are system-related, like Node, Java, and Yarn, if the developer updates the OS, they might break their application. That's one of the reasons why Docker is so popular, as it freezes a very specific OS state into a container that happens to work for a given project. After all, when having a problem, why not create a new tool to work around it instead of fixing the cause, right? That's modern web in a nutshell. One remarkable example can be seen in GitHub's blame page. Because it implements this stupid React viewport optimization, if you use the browser search feature to look for anything outside the viewport, the result will be empty. What did those geniuses do? They created their own search feature powered by React and garbage NPM packages, resulting in almost 3 megabytes of minified JavaScript code. If they could only know that simple static HTML can easily render interactive tables with thousands of rows even on a mid-range phone. Faster than a turtle, or maybe not. In a 2015 presentation, Tom Okino, one of React's core developers, said the following, and there is a link here to the YouTube video. People started playing around with React internally, and everyone had the same reaction. Okay, I have no idea if this is going to be performant enough, but this is so fun, I don't really care if it's too slow, somebody will make it faster. People started playing around with React internally, and everyone had the same reaction. Okay, I have no idea if this is going to be performant enough, but this is so fun, I don't really care if it's too slow, somebody will make it faster. Are you kidding me? They all knew that in JavaScript land, the more abstractions, the worse the performance. They were just hoping for someone to perform some sorcery, which, as we know, never happened and probably never will. Fast forward to 2018, when Netflix announced that they migrated their portal from React to vanilla JavaScript, managing to reduce JavaScript bundle size to 1/5, which resulted in 50% faster loading time. There's another link to that video there. Or an article, maybe. I think it's an article. In 2020, Jeremy Wagner wrote this amazing article where he conducted some performance tests comparing React to Vanilla.js to show one component on the screen. We're not talking about Vanilla.js being twice faster. No, we're talking about 24 times faster. What is this article? What is this study that was done by this unnamed or named hero? Well, I just so happen to have it. And we're going to frickin' go over it. Article by Jeremy Wagner on August 19th, 2020. How did he come to such a conclusion about React? React is popular enough that it receives its fair share of criticism. Yet, this criticism of React isn't completely unwarranted. React and React DOM total about 120 KB of minified JavaScript, which definitely contributes to slow startup time. When client-side rendering in React is relied upon entirely, it churns. Even if you render components on the server and hydrate them on the client, it still churns because component hydration is computationally expensive. React certainly has its place when it comes to applications requiring complex state management, but in my professional experience, it doesn't belong in most scenarios I see it used. When even a bit of React can be a problem on devices slow and fast alike, using it is an intentional choice that effectively excludes people with low-end hardware. If it sounds like I have a grudge against React, then I must confess that I really like its componentization model. It makes organizing code easier. I think JSX is great. Server rendering is also cool, even if that's just how we say send HTML over the network these days. Still, even though I happily use React components on the server, or Preact as is my preference, figuring out when it's appropriate to use on the client is a bit challenging. What follows are my findings on React performance as I've tried to meet this challenge in a way that's best for users. Setting the scene. Lately, I've been chipping away at an RSS feed app side project called bylines.fyi. This app uses JavaScript on both the backend and front end. I don't think client-side frameworks are horrid things, but I've frequently observed two things about the client-side framework implementations I tend to run into in my day-to-day work and research. Frameworks have the potential to inhibit a deeper understanding of the things they abstract, which is the web platform. Without knowing at least some of the lower-level APIs that frameworks rely on, we can't know what projects benefit from a framework and which projects are better off without one. Frameworks don't always provide a clear path toward good user experiences. You may be able to argue the validity of my first point, but the second point is becoming more difficult to refute. You might remember a little while ago when Tim Kadlec did some research on HTTP Archive about web framework performance and came to the conclusion that React wasn't exactly a stellar performer. we have been through, I think it might have been this exact article before. But essentially, this person broke down the cost of like what it costs in terms of size, right? Package size, okay, to serve up sites on particular frameworks. So bytes served to the desktop and mobile broken down. The execution time, right? jQuery, Vue, Angular, React being the worst offender. Scripting related time on desktop, and so on and so forth. This is an article that I'm pretty sure I've done before, but let's keep going. Still, I wanted to see if it was possible to use what I thought was best about React on the server while mitigating its ill effects on the client. To me, it makes sense to simultaneously want to use a framework to help organize my code, but also restrict that framework's negative impact on the user experience. That required a little experimentation to see what approach would be best for my app. The experiment. I made sure to render every component I use on the server because I believe that the burden of providing markup should be assumed by the web app server, not the user's device. However, I needed some JavaScript in my RSS feed app in order to get a toggleable mobile nav to work. Okay? So far, nothing crazy here. This scenario aptly describes what I refer to as simple state. In my experience, a prime example of simple state are linear A to B interactions. We toggle a thing on, then we toggle it off, stateful but simple. Unfortunately, I often see stateful React components used to manage a simple state, which is a trade-off that's problematic for performance. Though that may be a vague utterance for the moment, you'll come to find out as you read on. That said, it's important to emphasize that this is a trivial example, but it's also a canary. Most developers, I hope, aren't going to rely solely on React to drive such simple behavior for just one thing on their website. So it's vital to understand that the results you're going to see are intended to inform you on how you architect your applications and how the effects of your framework choices could scale when it comes to runtime performance. The conditions. My RSS feed app is still in development. It contains no third-party code, which makes for easy testing in a quiet environment. The experiment I conducted compared the mobile nav toggle behavior across 3 implementations. A stateful React component, rendered on the server and hydrated on the client. A stateful Preact component, also server rendered and hydrated on the client. And a server rendered stateless Preact component, which was not hydrated. Instead, regular old event listeners provide the mobile nav functionality on the client. Each of the scenarios were measured across 4 distinct environments: a Nokia 2 Android phone on Chrome 83, an Asus X550cc laptop from 2013 running on Windows 10, Windows 10 on Chrome 83, an old first-generation iPhone SE on Safari 13, and a new second-generation iPhone SE also on Safari 13. What was measured? Startup time, hydration time, mobile nav open time, mobile nav close time. It should be noted that measurements of these behaviors include scripting time only. Any layout, paint, and compositing costs would be in addition to and outside of these measurements. One should take care to remember that those activities compete for main thread time in tandem with scripts that trigger them. The procedure: remote debugging in Chrome, local network with toggling, throttling network performance, recording, profiling, and reloading the page. You'd open the mobile nav menu and then close it. You'd stop the profiler and record how much CPU time was involved in each of the 4 behaviors listed earlier. Then you clear the performance timeline and also click the garbage collection to free up any memory that's included. I repeated this procedure 10 times for each scenario for each device. 10 iterations seem to get just enough data to see a few outliers while getting a reasonably accurate picture, but I'll let you decide as we go over the results. If you don't want to play-by-play of my findings, you can view the results at the spreadsheet and draw your own conclusions, as well as the mobile nav code for each implementation. the results. Okay, so minimum, maximum, medium, average CPU times, right? Startup cost, Google Chrome on Nokia 2. React, Preact, add event listener code. The time differences between minimum, median, average, and maximum is wildly insane. This is one component. To remind you, startup cost in this case includes the time it takes for the browser to evaluate the scripts needed for the mobile nav to work. For React and Preact, it also includes hydration time, which in both cases can contribute to the uncanny valley effect we sometimes experience during startup. Preact is obviously a bit better. Okay. And then hydration cost alone. These numbers are wildly different. For React, this is still in the vicinity of yikes peak. Sure, a median hydration time of 70 ms for one component isn't a big deal, but think about how hydration cost scales when you have a bunch of components on the same page. Mobile nav open time. This is crazy. It's not even close. Like, it doesn't even hold a candle. This all started because someone got tired of writing add event listener a bunch of times at the top of a file. Yeah, that's exactly. Yes. A quick note on JavaScript samples. Before moving on to the iOS results, one potential sticking point I want to address is the impact of disabling JavaScript samples in Chrome DevTools when recording sessions on remote devices. After compiling my initial results, I wondered if the overhead of capturing entire call stacks was skewing my results, so I retested the React scenario samples disabled. As it turned out, the setting had no significant impact. How about Safari? It's not even close. You've Doctor Stranged yourself into an entirely different universe. How about mobile nav open time? 24 times. How about Safari on second generation iPhone? Even worse. How about mobile nav open time? Nope. How about Chrome on a dated Windows 10 laptop? Get out. How about hydration time? Get out. How about mobile nav time? Get out. Shadow call stacks for the win. It's not a mystery as to why it takes React and Preact longer to start up than it does for a solution that eschews frameworks altogether. Less work equals less processing time. While I think startup time is crucial, it's probably inevitable that you'll trade some amount of speed for a better DX, though I'd strenuously argue that we tend to trade too much toward developer experience than user experience. Yes, those were an MS. That's right, Laugh. Yeah. The dragons also lie in what we do after the framework loads. Client-side hydration is something that I think is far too often abused and can sometimes be completely unnecessary. Every time you hydrate a component in React, this is what you're throwing at the main thread. Recall that on the Nokia 2, the minimum time I measured for hydrating the mobile nav component was about 67 ms. In Preact, for which you'll see the hydration call stack below, it takes about 20 milliseconds. Games have to run their entire code in less than 16 milliseconds tops. Yep. That's right. So he goes on about the call stacks. You can see a call stack of React firing a click event handler to open a mobile nav. This is what happens in the call stack in your CPU when you click a button to open that mobile nav that we saw that pulls in. That's React. That's what this does. Preact at least strikes the middle ground. This is less bad. And here it is. Plain old event listener. That's it. It gets the job done 7 times faster on the budget device than React. Conclusion. Well, it's not a React hit piece, but there are pitfalls. Right? And so he's trying to be fair here, and I get it. But this is what you're onloading. This is the cost of accepting libraries, frameworks, and languages that obfuscate or abstract things away. Right? There's a cost to that. Seems insane to me to think it's acceptable that one thing is allowed to take up to 14 milliseconds. Yeah, because nobody uses that, so no support. What do you mean, Ghost? Also, Sparrow, there's something no one mentions about this. Okay, hit me. What's up? Oh, Preact. Yeah, you're right, Ghost. Yeah. No single instruction takes this long to execute. Yes. This is exactly right. No single instruction takes this long to execute. How many instructions are being executed for these things? Well, we saw the call stack, didn't we? Like, we literally looked at the call stack for it. So yeah, you have a very good point. It's a call stack with 1,000 functions. Yeah, this is the opposite of what should be done on my good evil scale. That I still have no name for it. Yeah, it is. It's not. It's an extremely lazy and dangerous way to tackle these problems. In some cases, these things might be unavoidable, and you might have to reach out for something that does this in order to get something done. There's no way I can say in whole, like, there is 100% never a reason to do this. But it is wild to me that this is defended as the de facto way to tackle problems like this over and over again. Material UI, one of the most popular libraries for React with 4 million downloads per week, is another example of the performance disaster in the React ecosystem. This is the total time spent with JavaScript in mobile mode loading a screen with just buttons. Same looking style. I mean, you can read a chart, right? 5,000 milliseconds up at the top, right? You start over here with around 500 buttons. The darker color is with Material UI. The lighter color is with no Material UI, or let's say vanilla. And as you increase the number of buttons, you can see we barely hit 500 milliseconds, maybe not even, whereas up here, we're at 5,000. Some people will try to mislead you with arguments like, no one will put thousands of buttons on a single page, when they're missing the point. These popular React packages are extremely inefficient even when compared to pure React, which we already know is slow because it's an abstraction over an abstraction. A static HTML, in comparison, takes 0 milliseconds in this test because it doesn't need JavaScript to achieve the same result. The increased entropy from Material UI affects not just the JavaScript process, but also the final HTML, which has twice the number of DOM elements and 10 times the file size. Again, from the user's perspective, both Material UI and React look exactly the same in this test. In React Native, if you have a flat list component with more than 50 items with just text, performance will suck and React will splash this BS in your face. Virtualized list. You have a large list that is slow to update. Make sure your render item function renders components that follow React performance best practices like pure component, should component update, etc. Now, if it knows what's wrong, why doesn't it do the right thing automatically by default? Well, that's missing the point. The truth is that it's simply unacceptable that in 2024, people are still trying to convince us that something as simple as a list could be slow in any reasonable scenario. It gets even more surreal when we read React's official documentation. Here are a list of props that can help to improve flat list performance. Remove clipped subviews. If true, views that are outside of the viewport are detached from the native view hierarchy. Pros. This reduces time spent on the main thread and thus reduces the risk of dropped frames by excluding views outside of the framework from the native rendering and drawing traversals. Cons. Be aware that this implementation can have bugs, such as missing content, mainly observed on iOS, especially if you're doing complex things with transforms and/or absolute positioning. Also note, this does not save significant memory because the views are not deallocated, only detached. React has no self-respect to the point it admits its code can have bugs and even calls absolute positioning something complex. Really? If this doesn't sound pathetic, let's try a different approach then. In 1997, ID Software released Quake 2, a 3D accelerated game that was capable of delivering 60 frames per second on machines from that time. This means that every 16 milliseconds the engine had to process hundreds of polygons, textures, and dynamic lights, AI, physics, animations, multi-device input, multi-channel audio, I/O, network sync, HUD, etc., etc. We are talking about an application that is miles and miles ahead in terms of complexity compared to the vast majority of web apps we see nowadays. Currently, we have tiny machines in our pockets that are 100 times faster than the computers from 97. But still, a website that only shows a static table takes some seconds just to have its JavaScript code generate the HTML for the user. What went wrong? That we not just achieved this crap, but worse than that, we normalized it. Current web applications should be running at least 100 times faster than Quake 2 used to run, and on machines from that era. Yeah, laugh. Vindicated. That's right. Developers seem to have no idea how fast HTML and CSS can be parsed and rendered. The slowness of the web is not caused by these two guys unless the developer is doing something amazingly stupid. Even vanilla.js can perform decently when used with parsimony. For instance, it can parse 1,000 entries JSON and populate them into an HTML table in a tiny fraction of a second. It's so fast that after downloading the JSON, no asynchronous call is needed for the rest of the process. Imagine that. All the optimizations that developers have been hungry for to avoid low performance on the web is mostly caused by the inefficiency of these bloated frameworks and their packages. It's completely nuts that modern tools normalize the concept that it will deliver crap by default, and it's up to the developer to find a workaround if they don't feel happy with the result. Imagine a car manufacturer telling mechanics, make your client's car work properly by optimizing the engine. Oh, and good luck trying to find external help to fix the issues you're facing, because for each situation, there are dozens of answers that may or may not apply depending on the magic combination of tools and versions behind the application. And there are so many combinations that chances are your case is unique. It's not uncommon to read things like answer A didn't work for me, but answer B did. JavaScript bundle therapy. There are countless tools to parse and bundle the JavaScript code of web applications, but Webpack is by far the most popular one. It's no surprise it's written in JavaScript because why not, right? What is amazing though is how terrible it performs, not just regarding CPU performance, but especially memory-wise. 5 gigs of RAM to bundle a React application with 150,000 lines of code, not including the dependencies. All this obscenity is seen as normal nowadays. No one bothers to question it anymore. We're supposed to shut up and be grateful for this rubbish ecosystem. What's even more annoying is that Webpack's main mission is not accomplished decently. Instead of removing all unused JavaScript code, the so-called tree shaking, it insists on bundling useless code that will never be reached. For example, imagine class A. Import React, import my_enum from class B. Here's class A as a constant with an inner function, if my_enum, spit out hello, and class B. Import React, pull in the CSS baseline from Material UI, export the enum item, go into the class B with an inner function, return a div with CSS baseline. Because class A is importing this decoupled enum from class B and it doesn't use CSS baseline, we would expect the JavaScript bundler to exclude it, but that's not what happens. In other words, it will recursively bundle all the imports of the declared classes. When you sum up all those mistakes, the result is something like this. Hang on, I need to take a sip of coffee. But if the code is not being used, that shouldn't be a problem, right? We have to remember. I see he goes over used versus unused, right? 50% of unused code. We have to remember that JavaScript code is usually downloaded, parsed, and compiled on the client side. So, depending on its size and the machine, it can result in very poor performance even after caching. Not to mention shorter battery life. That's the main reason why most applications ship their code in the so-called minified version, just another workaround to optimize something flawed in its concept. Sometimes I wonder if web development is not just a prank. Just take a look at this yarn nonsense when you try to call yarn install package. Yarn install, it's been replaced with add to add new dependencies. Run yarn add React Native CLI instead. Developers behind Yarn simply decided to remove a well-established keyword used to install packages, and to make matters worse, they added a message to teach the user the right way of doing it, which is way more work than just installing the thing since they know exactly what the user is trying to do. There's some sadism in these guys' souls. Look at this. Orphan Yarn files, because yes, congrats for the asymmetric number convention. How far the web crap can go. What about server side then? It's probably more sane as it has to be efficient and reliable, correct? Well, since 2009, when Node.js was released, all kinds of servers have been created and ported to this JavaScript framework. At this point, it couldn't be more predictable the fact that Node.js is mainly written in JavaScript, a language that is very limited, inefficient, and clearly not designed for anything close to handling a server. There's not even support to multi-thread. Let's step back a bit and think about what's happening here. In a static compiled language like C++, C++, or Rust, the developer compiles the application once so users don't have to do it ever. Now, with JIT, compiled languages like JS, not only does each user have to compile the code, but every single time they run the application, it has to be compiled again. Not to mention that even after compiled, JavaScript will not perform as fast as a static compiled language. Finally, stack on top that all this garbage code introduced by JavaScript frameworks, the magnitude of inefficiency is just insane. Okay, let's avoid online applications as much as possible because most of them are clearly screwed. Let's try desktop versions of the applications we need, like Postman, this tool made to test endpoints. We've used Postman before, right? It's just a way to test API endpoints and pass data around and see the inputs and outputs of your endpoints, right? That's all it is. If you smell web in this desktop app, you're not wrong. Postman is written using Electron, meaning it has a full Chromium browser embedded, including DevTools, libffmpeg, etc. And surprise, it's written in React Native. That's right, Ghost. It's an Electron, so it needs an account. And here you go. React Native. Yes, your desktop application is, in reality, a browser accessing React Native code that depends on countless packages just to generate mundane HTMLs. So what's the price for all that? Well, in version 11.3.2 for Linux, there are 22,000 files taking 410 megabytes of space storage and more than 700 megabytes of RAM to load the offending initial screen. I just would like to read this to you one more time. In version 11.3.2 of Postman for Linux, there are 22,000 files taking 410 megabytes of space storage and more than 700 megabytes of RAM to load the initial screen. They want us to believe that the newest curl 8.8.0 for Linux, while more powerful and having only 3 files, taking 1 meg of space storage combined and consuming just 10 megs of RAM, is this light because it has no UI. Sure. Sure, you can see 30 megabytes down at the bottom. Might be a little difficult to see, but you can see down at the bottom. And you can see that the load time to the point where it finished was around 1700 ms. Right around here, it seems to have finished. Postman needs over 25 megs of minified JavaScript to show a login screen. This Electron nightmare is everywhere, including many popular desktop applications such as Discord, Dropbox, GitHub, Teams, Spotify, Visual Studio Code, WhatsApp, etc. They all behave similarly to Postman, and in the mobile realm, it's no different because most software companies don't want to invest money in a different application for each platform. So if a web application also has a mobile or desktop version, chances are they all are written using some sluggish JS framework and come with an embedded browser. In the past, a flexible programming language would be multi-platform, and the compiler would be responsible for generating a binary for each platform. But because JavaScript compiler is in the browser, developers see no other way except shipping their desktop and mobile applications with an embedded browser. By the way, browsers nowadays are huge monsters that have more lines of code than the Linux kernel. The only realm untouched by JS is then the operating system, right? Nope. On Linux, the most popular graphical environment, GNOME, has 50% of its shellcode written in JavaScript. What's this? What what's this? What's going No. What This is JavaScript. No. Tell me it ain't so. You can't tell me it ain't so, can you? No, because it's JavaScript in GNOME. And third-party extensions for GNOME have to be written entirely in JavaScript. PolicyKit, a popular Linux application that allows unprivileged processes to speak to privileged processes, also depends on a JavaScript engine to work. Firefox version 128.0 source code, more JavaScript than any other language. A glimpse of sanity. What's the solution then? While I could argue that static HTMLs would be enough for most web apps, it's understandable that a developer might wish for certain conveniences like templates or components, automatic DOM update, support for third-party plugins, etc. Luckily, the world still has a few sane people, and some of them decided to create SvelteKit, a lightweight multi-platform framework focused on performance that gets faster and smaller each major release. SvelteKit doesn't impose any of the BS trends promoted by React, and out of the box, it does what we expect from a tool. It helps developers while providing a decent experience to the users. SvelteKit highlighting, and I will agree that some of these things that are called out like code splitting, so that you only the code you need for the current page is loaded. That's great. Asset preloading, so that waterfalls of files requesting other files are prevented. File hashing, so that your assets can be hashed forever. Like these are all like good things. But I would actually throw this back at the author's face and go, do you even need these things? Are these are these goals not able to be accomplished using other methods that we have available without a framework? However, if the web application is intrinsically complex, JavaScript is just not suitable, period. And then we get to the bad part. In this case, I'd recommend using Blazor, which uses WebAssembly to run C# code directly in the browser. No, I'll pass on that. But this is good. Perhaps the most important thing is to avoid over-complexity. React is just one big example, but there are many other ways to add unnecessary entropy to your project. Do not assume you have to fight code for days just to implement something trivial. Start with the absolute simplest ecosystem possible, experiment with things. Avoid dependencies as much as you can. The fewer moving parts, the better. If things start to become too complicated or you feel you don't have much control over what's happening under the hood, go back and challenge your team to think outside the box. It's totally fine to give up on things if they're not going the right direction. At this point, we have many decades of human experience in the field, amazing hardware and tools, so there are no excuses. And then a lot of people were complaining, well, then you posted this on Medium, which is like a really bad place to post it. It's like, well, good exposure though. So then the last thing I'm going to do not this. We're going to read some of the comments. Because some of these are very good. So I'm going to take a break for a second. And we're going to read some of the comments. We're going to get into some of the rebuttals from people because there were definitely a few. And then I'll end the stream. Yeah, no ships today. It's all boring code. It's too boring to watch me do cleanup code on the ship game. Hey, Team JetBoop, how's it going, man? Thanks for popping in. Okay, let me just do one or two quick things here, and then we'll just keep going. All right. Okay. So after reading all that and watching all those videos, let's read some of the comments, all right? We're going to read two series of comments. One is going to be from the Medium article itself, and one will be from the Hacker News posting of this, because there are some people who push back on it, and it's important to hear the pushback. I very much enjoyed reading your article, and I can relate to almost all of your experiences with the JS Madness ecosystem. But at the end, I was very surprised to see that you still recommend Svelte and client-side HTML generation. I ditched all client-side frameworks and packages for my projects, both hobby and professional. Back to SSR, proper HTML, CSS, and JS where it's really needed. Best decision ever. And the author says, I'm glad you enjoyed reading the article. Regarding your surprise, I'm sorry if I wasn't clear enough. I meant to say that, like you, I would recommend HTML, CSS, Vanilla.js for almost all web applications. However, I understand developers who want some of the conveniences provided by frameworks, and for them, I would recommend Svelte because it's light and straightforward. Personally, I would not use Svelte if I had a choice because the raw option is much easier, faster, and more reliable. What I've been noticing is that developers nowadays are afraid of implementing features from scratch, even if they're not complex. LeftPad and IsOdd have entered the chat. Instead, they want to use as many packages as possible because it seems easier and more reliable. The irony is that most of the time, they are not. I agree with a lot of your sentiment, but this one I have to disagree with. While some developers may be afraid of developing features from scratch, the vast majority either don't have the time or want to use something that the next person who maintains this has a chance of being familiar with. And of course, many devs don't get an option here. The answer is predetermined by the company or client they are working for. Not to say that this is a good way to go, but I think reflecting the sad reality here is important. Understood and agreed. And I would actually counter back to this person with, it doesn't matter. It doesn't matter whether there's a pushback or a predetermined state of things. If you do not try and escape this box, or at least understand fundamental things so that you can do them yourself, you will never be able to make an argument why you should do these things when the opportunity arises for you to say something that might change the course of this sad reality. So the defeatist idea that you should just give in and accept the fact that, hey, if you're afraid to do something, don't do it because, like, what choice do you have? You might as well just go with the status, go with the flow, is a bad decision to make in the long run. It might be a good short-term decision, but not a good long-term decision. Isn't that how you got fired for using HTMX? Yeah, because a new CTO came into the company and was like, "Oh, you're single-handedly running this entire website by yourself with HTMX and PHP because you kept it so simple? No, I want to hire a team of React developers. Off you go." New day, same story. Your complaints sound like a skill issue. Most musicians are terrible at Guitar Hero, but are obviously more skilled. Your response clearly shows you're in the Guitar Hero class. Your comment really had no single argument. Can you please elaborate? This guy right here is why we are where we are. Programming is not a true profession, so any schmuck can claim to be a developer. I think anger at an evolving landscape attempting to better itself is why you are where you are. Keep complaining. The rest of us will keep building. Building crap that increases the warming and degradation of our planet, screws over other engineers, and is completely devoid of any pride or excellence. I bet you're fun at parties. That totally depends on the height of the egos around me. Andrew, yes, it's a skill issue in a way. JavaScript and web development have always had a low barrier to entry, and the result has been dev teams that are not as qualified as those who develop server-side code. Sweeping generalization about the qualities of a particular subset of professionals based on their area of expertise. Reality is a bit more complex and nuanced than that, my friend. I've been doing software, well, not anymore, I just retired, for 40 plus years, and witnessed firsthand the advent of the web through its many developmental permutations. In that time, I've worked with a few genuinely brilliant web engineers. Doing web front-end doesn't mean you're a bad engineer, but what I've mostly seen is that web front-end devs are just not as skilled in software engineering principles. Whether that's because it's easier to learn HTML, CSS, and JavaScript, so there are more web devs that are junior or lack formal training, or because the environment just doesn't allow software to be structured robustly, resulting in bad habits, I can't say. Yeah, going rogue in a big company can be dangerous, but if nobody does it, then nothing ever changes. That's the point. Not doing it means that all you're doing is perpetuating whatever's happening. You're not making any changes. You're just accepting the changes and continuing them. Many job postings feature a tech stack that includes at least 2 front-end frameworks, usually Angular and React. I think it's a ghosting tactic. Yeah. Team Jetpoop. I can see from this discussion thread there are jumbling up all kinds of ideas until nothing definite is being learned. Idea 1. Big JS ecosystems exist for big teams, not just big web teams like New York Times, but also thousands of solopreneurs. A big number 2, just educating them. 2. Big teams being forced to squish all the functionalities into the same spa, but if the world wasn't run by the same non-thinking CTOs, then web pages, web apps would have more room to breathe. There would be far less spa, and that makes room for idea 3, which is simple JS, handcrafted, no React, which then leads to 4, things like HTMX feel natural, no spa. So we got to essentially trade big web teams for new hotness, lean organizations with a max of 22 employees. That's how I look at this discussion thread. It's a mix of ideas. Unless we break up the separate ideas, nothing makes sense. We'll never move the needle. I would actually argue why yeah, we probably agree. I think we agree on pretty much everything. Yeah, I think even in a big team, you probably don't need to be doing these things. You could have a big team and not having this crazy set of like complications, but if that's true, then yeah, you would actually run with a leaner team because you would be doing more like simpler things. So yeah, Another response. I agree with a lot of what you said. The unfortunate obsession with React, the dependency hell, the bloat of Electron apps. The reason we don't get out of this mess easy is that we educated a whole generation of developers to work exclusively with React, and the job market rarely offers an alternative. Still, I was quite surprised that you claim JS is interpreted, where it has been JIT compiled for more than a decade. Also, React and React Native are completely different beasts. Node might not be the fastest environment, but mostly it competes with Java and PHP. Apart from gaming, I don't see a lot of use cases for WASM, and I strongly doubt that it will make your projects simpler. Thanks a lot for the clarifications, says the author. I changed the article to mention that JavaScript is JITted. Regarding React and React Native, don't you think they have enough in common to be mentioned together in an article criticizing the web development mess? Both share a similar syntax and core concepts, but React Native's purpose is to build mobile apps, which makes them rather different. Example, it creates mobile API components, not HTML DOM. Okay. While you've used a shockingly negative tone in this article, there's our tone policer. There's always some tone policer somewhere. It's hard to disagree with the facts that you've brought up here. I've experienced many situations, especially lately, of dependency mismanagement, application code disorganization, and component bloat. It's very disappointing to see how the monorepo and micro frameworks have gone from the fringe to an everyday occurrence, often without good cause. However, when a React project is well organized, the dependencies are kept minimal and components modules are kept small. It's fun to use. It feels more natural to me, but probably also to many others, than Vue, Svelte, Alpine, Angular, even than vanilla. And it has an ecosystem, for better or worse, built up over a long time. Are we at decades yet? Yes, you write JavaScript in your HTML, just like PHP and HTML intertwine, so that you can see that something happens here. Okay, React is asynchronous. In what world is the internet instantaneous? Should we unload the page every time and wait for the server to do the work, flashing an empty white page while the browser waits for a response? That's a hard sell to any client willing to pay a livable salary. This is based on the assumption that servers are not fast enough these days. This is this is like saying, like, if you remove React, you automatically push a magic button that time travels you back to early 2000s when servers couldn't handle server-based operations fast enough. Except that today they can. You don't need React. I posit that React is fun, just like driving a car is fun, and what you've sort of done here is complain about how complex a car is under the hood, and gone further by saying that it's crazy that we need tools and parts that make the parts that make the parts that go into the car. All the while, you say that horses have gotten faster and we should just go back to riding them all the time, also pointing out that bicycles are a viable option. Perhaps it's not perfect, but everything has its place. A React app with all its complexity is great when you want to create interfaces that interact asynchronously with data and you want to work fast, perhaps even alone. An HTML website is perfect for most sites, displaying simple info that changes infrequently. But I like what you've written here because you'll ruffle feathers. You've ruffled mine and reinforced my belief in how to get things done more simply. The problem is that React is not just intrinsically slow, verbose, and hard to debug, bringing essentially no benefit to anyone, especially the user. It's the fact this well-organized thing you say is just too hard to achieve in practice. The issue starts when we create a Hello World project and it comes with 40,000 files, countless dependencies, crazy infrastructure. And the application at this point is doing nothing except printing a simple message. The whole concept of client-side rendering is just nuts, and the issues that React promises to address don't affect most web applications in the first place. In the end, it's more about mimicking what big tech companies do, which makes no sense, especially when we take a look at how garbage meta products are. The React ecosystem is more than 10 years old now, yes, but how many versions have required a complete rewrite of our applications? What's the real benefit here? Now they're finally trying to convince people that server-side rendering is better, after more than freaking 10 years trying to convince us the exact opposite. The same applies to Webpack, which is now being replaced with RSPack, which is written in Rust, which is much faster to bundle. Of course, in this insane web dev world, nothing comes for free. RSPack generates larger JS bundles, so from the user's perspective, it's worse than Webpack. Should we unload the page every time and wait for the server to do the work, flashing an empty white page while the browser waits for a response? I see what you're trying to say, but that's a common misconception among React developers. Everything you write using React will always be converted to vanilla JavaScript by your transpiler. So if something can be achieved with React, it can be achieved with vanilla JS as well. It's not just that. As I mentioned in the article, we don't need everything to be asynchronous, just specific tasks like server requests, which can be handled asynchronously in vanilla JS using fetch. Once you understand that React is just an entropic layer and that vanilla JS is much easier and faster, you'll realize the trap you've gotten yourself into. It's never too late. Even vanilla JS can perform decently when used with parsimony. It's well beyond decent now. With the JS engines of the last few years, you can get almost compiled code performance in some cases faster than Swift with safe array types. We tested it. It is truly shocking. You don't even need JS Hermes engine. The default engines are fine. If you are doing pixel level image processing, JS will probably be slower than unsafe memory code like C or C++, or say video decompress. But if you are experiencing performance hits on modern browsers or in React, it seems far more likely that the rendering engine or DOM ops are causing them than JS. It's fine. Yeah. I don't think there was anything in here. Whenever our React Native project won't build because Xcode has changed, or React Native has changed, or one or more of the 1,000 node modules has changed in a breaking manner, all you have to do is change X to use the new version. Of course, when one package writers say all you have to do, all can become huge. I search for articles like these to quell my mental pain. We salute you. You are doing us a service. HTMX CEOs are welcome here, not just welcome. I am the lead. I'm the lead HTMX CEO. I literally have lead HTMX.ceo. That's me. And I've interviewed Carson on this channel too before. And like I said, I've used HTMX on a massive website. I got fired for it because the CTO wanted a team of React devs. Wow, that was a lot to take in. It must be nice to think of the good old days as some utopia where everything was fast, simple, and reliable. Well, I was coding in the good old days, and it wasn't all unicorns and rainbows. You say we started with crap and added more crap on top. This is a very naive way of looking at this. In reality, what happened was there was a problem, a solution was found, and that solution became popular because it solved that problem well. This, my friend, is called progress. You clearly don't understand how HTML, CSS, and JavaScript work. Take the time to learn how computers work under the covers, then how browsers work, then learn how business works. No matter what you do, you will always have compromises. There is no magical solution to all the problems you face. Each solution will introduce new problems to solve. You need to learn how to evaluate these compromises and which ones you need to make to be successful in your solution. Then and only then will you be in a position to critique these compromises and propose a solution that has the compromises that are acceptable to your situation. Right on. I'm with those who say, step 1, write an only well-formed semantic HTML to establish functionality and accessibility, add classless CSS to make it pretty, and add minimal JS if absolutely necessary. Programming is not a profession. You cannot just call yourself an electrical engineer or a stationary engineer. You must have the proper credentials. Software development is open to literally anyone, and millions of low-skilled people do this job globally. This wasn't the case 50 years ago, when the quality of most systems was vastly higher. Example, software helped take us to the moon on hardware that had thousands of times less power than a smartwatch. Nothing has changed. And yes, software development is a profession, like being an electrician or a lawyer. The problem is with terminology. The phrase software engineer has been accosted to replace the more accurate term, software enthusiast. If you don't agree with me, then I feel you probably simply have never met a true software engineer, which honestly isn't surprising. I myself have only met less than a handful in the 25 years of software engineering I've been involved in. Most are cockroaches, I openly admit this, but let me assure you that software engineer, in its true meaning, is absolutely a profession, and if you are ever lucky enough to meet a real one, you'll understand. Modern developers switch jobs every few months. Playing to trends is understandable, and so are the consequences. That sounds like a nightmare. I've been a programmer for 40 years. I've only had 3 employers. Guess those days are over. Amazing. I agree with everything. I have been saying the same thing for years now. Why can't people see this? I assume it's because there are companies making lots of money out of this mess. I remember the JS-only app days. There were often huge piles of spaghetti with no structure or consistency. For complex apps, some sort of framework is necessary. For complex apps, just avoid JavaScript. And use what exactly? I think WebAssembly is the future, but JavaScript runs the internet and will for years. It now has massively encroached on the server side. Not bad for a Netscape 1990s macro language. Well done, Mr. Ike. Many moons ago, I built a website for a live events company which handles tens of thousands of visitors per day using plain vanilla HTML, CSS, and JS with PHP, and it never misses a heartbeat. Orders are processed quickly, customer queries are received without any issues, and the non-bloat website helps the company generate huge profits. Web development is overly complex by design these days because if you're using React, it's easy to explain how complex it is to a non-technical customer simply because React is complex in terms of what you get out of it versus what you put in it, and you can charge more. It was good days when I wrote web apps on Bare Metal DOM. It was a ticket reservation system. Think of it as a really big system, but it consisted of only 200 KB JS code. Okay. Every one of the frameworks produced totally bloated and inaccessible code for people with poor eyesight. None of them produce semantically correct HTML. No one cares until the customers complain or the company gets sued. Not sure when you would ever get sued for not providing semantically correct HTML. I wholeheartedly agree with everything mentioned in your excellent article, and I enjoyed reading the comments too. Some of the comments were very predictable. Despite your well-hung arguments, some people will defend the use of memory hogging, battery zapping libraries and frameworks to the death, just to simply display a simple text page with a few JPEGs, tut-tut. Browsing websites built with React and the like is excruciating. While React devs may find it fun to use, as some have said here, the same can't be said for the end user, and I say that without ambiguity. I can see in real time my remaining battery percentage drain before my eyes when jumping from website to website or even when switching from page to page. Web development for many years now has become a race to the bottom. It's incredible how its current state has become accepted as the norm. Relying on packages, which in turn rely on other packages, is begging for trouble, as most web devs are very good at plugging things together, but it seems many simply can't code themselves out of trouble and rely on other packages to implement fixes or add new features. It was only a short while ago that panic was brewing in the React community. When there was silence from the React dev team, there were rumors that continued React support just may come to an end. I found that quite amusing. I simply thought, if you built from good old vanilla, there would be no reason to panic. I'll be starting a project soon, which will be desktop mobile app with web to complement it. For the web, I'll be using strictly HTML, CSS, JS on the web, with little to no libraries, and certainly no frameworks. And as for desktop mobile apps, I may rely on .NET MAUI, or maybe even Flutter for the GUI, but certainly not Electron with its sometimes dodgy text rendering on certain GPUs and overall sluggishness. Absolutely bang on the money. Frontend is a hot mess and getting worse. JS and its associated frameworks have been the biggest enabler for mediocre developers and hobbyists to enter the software development arena without a care in the world for solid or at least sane engineering practices. The amount of unsustainable crap out there is absolutely shocking, and shitification and rot everywhere. Nowadays, web apps have much richer interfaces than decades ago. Trying to build a modern UI in an old ecosystem is real pain. Me, Next.js React is a breeze compared to Vanilla.js, even though the fast evolution also brought some garbage like mixed function components with class components and mixed async code with promises. Yet, I still don't see why React leads to fight code for days. Maybe you can elaborate on your experience a bit further. New projects introduce many new concepts, and some ideas make their way into the longer standing projects when experimentation is over. That is the evolution of these projects. Sure, it comes with bumps on the road and increasing page weight, but modern web apps are nowhere near comparable to those from decades ago. If the author replies, if adding triple the code, confusing syntax, callback hell, complicated and fragile infrastructure, updates that require rewriting applications, worse performance for developers, and significantly worse performance for users aren't enough for you to consider how problematic React and its ecosystem are, I don't know what else would convince you. Even the developers behind it admit it's slow. Maybe you should try building an application using Vanilla.js and see how it goes instead of clinging to old memories. Above all, you seem to miss the point of the article. New isn't always better. The driving force behind all this technological frenzy is profit, and we need to be critical of what's being offered to us. And then another article link regarding fighting code for days. I've worked in web development for a long time, and I have many friends and former coworkers in the same situation. We've seen countless instances across different teams, companies, and countries of people spending large amounts of time to implement simple features or fix trivial bugs using these trendy web frameworks. The problem is that this has become normalized. Many people have never experienced anything different, so they assume it has to be this way. Tip, it does not. Then there's someone asking about WASM and stuff. That's fine. Somebody making a joke. Somebody generally agreeing. Boilerplate stuff. Okay. This one's a touch interesting. Just one thing. Today, browsers pretty much try to obey standards, but that wasn't always the case. From the time browsers became the premier rendering tool for end users until around 2020, they often varied in fundamental ways. Some of the younger developers have never experienced something like endless debugging and rewriting of code because stuff ran on Netscape or Firefox, but not on Internet Explorer 6, 7, 8, 9, 10, 11, just pick one. This is actually quite true. I would agree with this statement in a vacuum. jQuery was mainly a tool to bridge the gaps, or the differences, between various browser vendors and their versions. Somehow, since 2015, the situation has started to slowly improve. Nowadays, as a not only but quite often front-end developer, I can afford to go fully native with server-side rendered, declarative, Shadow DOM templates, import maps, and ES modules and whatnot. I don't understand why these frameworks are still used and even thought of as the best thing since sliced bread, Yagni. Yet in the past, when we old-timers still carved petroglyphs into walls of rock, some of these tools, in particular jQuery, served as lifesavers. I think they developed a life of their own, like a religion, and people stuck to them, because it gives them some kind of consolation to use what most others are using. And yet again, only since recently are front-end developers able to cut off these ties to the past. Recursive Machine of Chaos. Found the right name for my band. This is also a good one. I agree with a lot of things you've mentioned. Coming from the embedded robotics domain, I was shocked about the overall state of web domain, over-engineering, framework fragmentation, tooling fragmentation, debuggability, performance with regards to latency, etc. If it's about plain websites, let's get rid of Next.js. Use lightweight alternatives if required at all, like Astro Build instead. Everyone forced to use Python in the back end is happy to visit Python Plain English, whatever this is, for ideas about how to avoid the front end and microservice bloat, and then Tori instead of Electron. About this Quake 2 thing reminds me of the saying, and I'm paraphrasing: the more speed and memory introduced, the more software can become crap. Is odd. Yeah. The product line I work for uses Angular. You can embed HTML template code into an Angular component, but I still create the separate HTML template for this very reason, to keep them all separate. Yeah, okay. Accurate. I'm a front-end engineer for 10 plus years at big tech. This is absolutely accurate and caused me pain. Along those lines, and sharing the same sentiment, I recommend watching on YouTube Casey Muratori's talk called The 30 Million Line Problem and Jonathan Blow's Preventing the Collapse of Civilization. The author says, I just watched the 30 million line problem. Thanks for suggesting. I've mentioned Casey Muratori at least twice in other articles, one about how BS has dominated the tech industry, where Jonathan Blow's presentation was also mentioned, and another about clean code. I think he's on the right side of the battle, but he makes too many mistakes and is too arrogant to the point he disables comments in his videos. The reason is clear. He doesn't want to damage his reputation since he sells online courses. In the video you recommended, for instance, he mentions the growing number of lines of code in the Linux kernel as something getting out of control. However, this growth is primarily due to the addition of support for new hardware. While he argues that hardware manufacturers should agree upon a standard, this expectation is unrealistic and unlikely to happen anytime soon. That does not negate his argument. This is kind of a stupid take. He makes an argument that is unrealistic, therefore argument bad. Another significant source of code in the kernel is the support for various architectures it runs on, including x86, x86-64, ARM, RISC-V, and more. Finally, there are many file systems. The diversity was simply much smaller in 95. Linux can be extremely fast. I developed a distro that can boot a modern PC in literally 3 seconds with no hibernation or cheating. It's ridiculously small and snappy. Not to mention, many small devices can boot even faster. So the amount of lines is not necessarily a problem, especially because in the case of the Linux kernel, most of the lines are not even compiled in each environment. Another mistake he makes is regarding the Mantle API, claiming it was invented to address bad AMD GPU drivers. That's just wrong. Mantle was created to bypass the abstraction layers of the two main 3D APIs, DirectX and OpenGL. Again, I understand this point. There was indeed a way to improve performance by replacing specific bad code. Thankfully, DirectX 12 and Vulkan did just that, and Mantle was deprecated. As much as I don't like the way software is developed nowadays, I have to admit that in some specific areas, things that require performance have significantly improved, like video encoding, decoding, and games. We can't deny how complex and performant games are today. Does Muratori really think that NVIDIA and AMD introduce overhead in their drivers just for fun? It's a fierce competition between these companies, with new players like Intel and several Chinese companies recently joining in. The amount of optimization these companies apply to each game in very specific scenarios is astounding. I bet a chunk of the drivers is made up of if-else statements to handle these cases, resulting in more lines of code precisely to achieve higher performance. What angers me is seeing simple apps that from the user's perspective are basically as complex as they were 20 years ago, but perform much worse on modern hardware. This is unacceptable, and that's why I wrote the article. We need to bring this problem to the table because younger generations have no good references and believe that JavaScript frameworks are the only viable solution when programming. Okay, that's a repeat. Yeah, React is madness and bloatware. Okay. This guy says, I think you should check your facts about React. React's virtual DOM is actually more performant than directly selecting and manipulating the DOM with vanilla.js. Regarding React performance, could you provide a source to support what you're saying? No source provided. Okay, and the last set of comments we're going to read are from the Hacker News version of the article because they also provide different perspectives as well. Hey, Team Jet Poop, thank you for the follow. I appreciate that. I missed it earlier because I was reading. Let me have one more sip of my coffee. After we read these comments, that's it. It's over. This was a slog of a stream. I appreciate everybody who was watching, but like, and nobody covers these topics. You've got people who like shill these things as like, you know, they're the things to do. You've got other programming channels. You know, that's what's going on in other programming channels. That what you're getting taught something apparently. Nobody that I know of is getting behind a camera. A very few, like Thread Interactive would be one. The other video we watched, you know, what you get is crap like this. Nobody's actually like willing to go through the slog like this and actually like read these articles, read these comments, break down the arguments, and try and present like here's a problem and here's how we can avoid the problem or come up with a solution. This is what programmers, especially the new programmers, need to see, not, you know, not anything else. At least right now. No, Lawler. I prefer the real ones. One sec. Okay, let me make sure that my layout is good, that it can be read proper, and my face is not. They're real ones. All you have to do is code them into existence. All right, so we'll go through these, and then I'll do like a whatever closing thing for the video, and then that'll be that. Okay, so in response to, again, this Medium article, let me maybe zoom in a little. React, and NPM for that matter, is not all web development, in the same way that Windows is not the only OS. Vanilla JavaScript these days is an absolute joy to code in, and highly performant compared to the past. Even lazy loading modules are supported natively by browsers these days. You can go a long way just using purely built-in default functionality. I avoid NPM and React and live my professional life quite happily without them, doing professional development using TypeScript and Angular with Bazel. For fun home projects, there is Dino, which is also lovely. Bun looks interesting, but appears to want to ape NPM, so it is a no for me. Response. So you aren't using Vanilla.js, you're using Angular, yet another framework. Incidentally, I've been working on a hobby project and for fun decided to use Vanilla.js to interact with all browser APIs directly, not even jQuery. It's been fun and easy, partly because modern web browser APIs have gotten so good and are very well documented on MDN. The point where Stack Overflow and LLMs don't really help much. It's been fantastic. If you want to enjoy pure HTML, CSS, and JS, try Van.js, a web components library. I don't think these guys read the original article, but anyways. I am not sure the author really knows what they're talking about when comparing today's web development with earlier systems. First of all, the reason for use effect is not directly asynchronicity. It's mostly an optimization to give React control over what code it needs to run when the state changes. This is because with React, you basically re-render a document with every state change. And in order to speed this up, React needs to know what code depends on what part of the state. Admittedly, not pretty, but all of the more automated model view controller-like systems have mechanisms to detect or handle model changes. They are completely wrong about asynchronicity. Since the 80s, GUIs have been using event loops. Windows 3.x did this, and even really old UIs like Gem did. When using an event loop, you must execute operations asynchronously, or the event loop will block. That's not new at all. What's new is that these days, applications are interacting a lot with the network, and these are blocking operations. They require asynchronicity in an event loop. This wasn't really the case back in the days before the internet, when everything was local, and for longer computations, you had to call functions like yield to give time to the UI. He mentions threads, but they didn't really become a thing before the early 2000s, and threads never worked very well with most UIs, except the good old BIOS. It's easy to complain about issues with today's dev frameworks and easy to overlook the limitations in the past. UI development was always a pain, especially for applications that are larger than the typical demo app. I have worked on apps using Gem, MFC, Qt, GTK, TCL, TK, AWT, Swing, JavaFX. It doesn't matter. It always sucks one way or the other. Today's web-based UIs and their dev tools are a marvel in many ways. They're like building pyramids. Like you can easily update them without going from computer to computer or let user run install programs. They easily adapt to all kinds of screen resolutions and screen orientations. You can easily debug them in a browser or even an end user's computer. You have package managers that make it easy to add and later update libraries. Certainly, not everything is perfect. I still kind of hate UI development, but it's a huge improvement over everything we had in the past. Whatever Kool-Aid this person's drinking, I want some because it clearly makes you a delusional dolt. And that's how I want to feel. It must feel good this way. Hard agree. They also glossed over JS using a single-threaded model precisely to avoid the huge mental overhead of dealing with multi-threaded models. I'm saying this is why it happened, and this is the problem they aimed to solve. I'm not advocating either way. The other thing they missed is why people move to React in droves is so simple it's possible we've just forgotten because it's a de facto approach. Co-location of declaration, behavior, and styling. React took us out of the X belongs with all the X things mental model and allowed us to create isolated X does this thing and looks like this, things that require far less mental overhead to drop in while making changes to a potential foreign code base. This is exactly why Facebook preferred React to the status quo. Engineers changing one thing in one place with predictable effects is wonderful for teams operating at wide, deep scales. Again, I'm not advocating for any of this. I just don't think skipping over history or twisting it into an unrecognizable ball gives any forward momentum to conversations about the evolution of UI UX. Hey, Slendy Dev, how you doing, man? They easily adapt to all kinds of screen resolutions. He thinks React does that? Apparently. There's your comeback. When it comes up, just ask what modern UI actually means. Further ask what old UI means. Yeah. That's exactly right. What is modern UI and what is old UI? That's right. And there's your differentiator. That's a good way to put it, Laugh. Just checking in? Good. I'm glad, man. Yeah, everything's going well here. I'm just having a rant. Okay. Then there's there's some, I wanted to skip that one. Okay. If all you have is React, everything looks like a spa. I honestly think the real problem is that we have a whole generation of web devs that only know React. I just don't understand React. It makes things slower, less responsive, just a worse browsing experience in general, all to serve JSON instead of HTML. The user experience is worse and the developer experience is worse. React was invented to save Facebook money on the billions of requests they get by sending minimal JSON data and having JavaScript do all the rendering. Under Facebook, I can understand it because it will save them millions in bandwidth, but for 99.99999% of other websites, it makes no sense. Also, another reason for React was to devalue front-end developers and make them easier to replace. Hey, Alex Jones, you want to put on another tinfoil hat? It's not about the rendering. It's about making sure all the state of the UI is consistent. That when text box A is changed, all the places in the page that depend on that value are updated. You can do it without React, but it's a real pain. Apparently, Facebook can't do it with React either. They still experience the same state inconsistency bug as described during React announcement as rationale for using React. What?
Where we had our most
Hang on, let me just pop this open. Make sure the volume levels are okay. I think it's all right. Let me just pop this open. Let's see what this is. Is Facebook not able to solve their own problems with their own tools that they said they built to solve their
where
own
we had
problems?
our most annoying chat bug happen over and over. Users would get an unseen count, and there would be no unseen messages behind it. You know, everyone's sort of used to seeing one of these numbers, clicking on it, and you get something new behind it. That's exciting, but when they get that number and they click, there's nothing there, they refresh the page and it's gone. That's really annoying. It's really frustrating. And that's what led to the whole fixed chat user feedback. And it wasn't like we didn't fix the problem. We would always fix like some particular edge case, but this problem would keep coming back just because the whole system was fragile.
Nani?
And that was a good sign that something was fundamentally wrong here. So
You
how
think?
can Flux help with something like this? If we're looking at the structure of the code that we had before, we have sort of the fundamental pieces. We have chat tab main messages, an unseen counter. And then we have an external handler that goes in and changes some of their state. They each have their own state, but the handler goes and modifies them, right? All of the logic to modify state based on a new message coming in is in the handler itself. And so those three different pieces no longer have the ability to maintain internal consistency. They basically don't have that information. They've already ceded that control to the handler.
Wait, aren't you the guys that made React in order to solve exactly this kind of problem? And you're like, hey, we still have this problem. And what React version are we on now? Oh yeah, 19. Okay. And then they're going back and forth on some details around this whole thing. There's also an entire generation of management gatekeepers that only approve of React stacks because the population of React devs is so huge they step over one another for a job. I have a moderately complex web application, lots of heavy compute in the back end, in which I wrote a perfectly fine browser-based vanilla JavaScript UI that is performant and does everything the application needs. However, ordinary users see it and say it looks so old, like early web, and they literally don't want to be seen using such old-looking software. Their reason for rejection is a fashion argument. They think it makes them look old using it. Okay, so I go looking for a front-end developer to make my vanilla JS look more modern, and I can't afford anybody except third-world React developers who work amazingly fast and build my UI as fast as I can tell them what I need. The front-end code is now 2 to 3 times larger than the back-end. The UI looks like just all the other single-page applications, and my new beta users are finally treating the project like this is viable new software and not some Franken monster of old and new. I actually receive useful feedback now rather than complaints that it looks so old. Couldn't you just hire a designer that would have made your app look better with just CSS? One would think, but they cost 2 to 5 times what I found just having it all redone in React. HTML, CSS, JS, and React are the worst solutions for graphical user interfaces except for all the others, though. Maybe immediate mode GUIs. React is bloated, slow, and overcomplicated nowadays, but unfortunately the only sane way to work with retained mode UIs. In my experience, working without React devolves to re-implementing React ad hoc. Also, there are many UI challenges solved easily by React plugins. Multi-select boxes, date pickers, color pickers, file uploads, etc. Yes, this is using a sledgehammer to crack a nut, but I don't have a nutcracker, and I do already have a sledgehammer, so why not? You gotta be fucking kidding me. What would the nutcracker be in this analogy? Good question. I suppose an existing plugin that meets the requirements or the skills to build one myself. It might be time for me to go live on a farm. I think I have to go like work with wood. I have to like go cut some wood and go live in a farm. I just can't. Hey Patroclus, good to see you. I think the author misses one of the main advantages of React. Transformation of application state into UI is a pure function. I've worked with a lot of different UI frameworks, mostly in game dev before switching to web dev, and I've run into a million issues that occurred because of procedural approach to UI. I think the main take is, it's okay to do stuff in JavaScript, but first we should have fixed JavaScript stupid stuff. Packages like isEven, isOdd, when created by one guy trying to solve JavaScript, a weird way to do stuff, and now we're widespread without considering all the effort could be used in a better way. This is kind of a weird way to say it, but you get the point. What? The modulo operator always existed in JavaScript. isEven and isOdd have always been stupid and unneeded. N modulo 2 equals 0, and N modulo 2 not equals 0 have never needed to be a dependency. Code is unclear. No one knows that % operator. Service companies which require you to produce code of offshoreable quality, as if someone without the skill to understand % can have the skills to understand how to translate your business needs into code. Nowadays, it's common for developers to learn React before they even learn JavaScript, and that's not great, but it's not the cause of the problem. It's the companies that pile on to a stack because it's easy to hire for. If everyone optimizes for hiring, we end up with a local maxima. React, we can't do better because no one else is doing better. And they talk about the medium, .NET MVC, get out of here with Blazor. Yeah, React examples. Although I don't agree with all the points, I have to say the amount of times a year I'm told with a straight face the following 4 lists with under 200 items in them is getting ridiculous. The truth is that it's simply unacceptable that in 2024 people are still trying to convince us that something as simple as a list could be slow in any reasonable scenario. Yeah, somewhere under the hood is a document get element by ID. It's no magic, and so the I don't know, he just says a whole lot of nothing here. I remember that. Hacker News, yeah. Turn JavaScript off by default, yep. Lectures on JavaScript and optimizations, yeah. Could have gone down the curl path, sure. The person writing this must have little to no experience developing UIs in classic frameworks. React has warts, but it is a decent implementation of reactive UI given the constraints of the web platform. Which constraints? Of course, you can achieve a speed up doing better than what React does with less context, updating only exactly the parts of the DOM that need to be updated. You will pay the price in terms of code complexity. As for async behavior, this is not something you can avoid, but cannot block on network requests or block until the user clicks somewhere. React does not push you towards async any more than the platform does. Yeah, React has flaws. Personally, I love web components and lit. Yeah, you can do all these things, but I still want to use React. Why React? Isn't it more complex? Yeah, but it has outstanding tooling, documentation, support, and a vast ecosystem. Almost everyone knows React, even if they don't like it. Despite my personal dislike, it's one of my go-to frameworks for new projects because of these reasons. If everyone jumps off the bridge, I'm going to jump off the bridge too. Why? Because everyone's jumping off the bridge. While there are performance issues, there are many experienced developers who can address them and yet don't. There are also a lot of very smart people working on various solutions, and yet where are they? At React 19. In summary, you can argue for any framework, but please don't believe that nobody knows what they're doing. That's not the statement that's being made. You completely missed it, and you're making massive generalizations. You're impugning generalizations on someone that were not being made. It's important to make a pragmatic approach. Pragmatism can come in all kinds of forms, and pragmatism of everyone else is doing it, therefore I, is not pragmatism. That's cult-like follower sheep behavior. Also, no, front-end developers were not thinking that React were rendering on the server all this time, and they also didn't think that static HTML would be slower or anything. Yes, many of them did. Absolutely, they did. You can just go look up just about any one of Theo T3's videos on anything doing with React, and he said that many, many times. So did many others. That said, I believe we'll see a new approach, framework, or technology that will pass React in the near future. Can't wait. While I appreciate the pragmatic organic growth and improvement, many feel that a restart is becoming necessary. Cool, yeah, about style sheets, Angry Man yelling at Cloud, Blazor, yeah, blah, 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 more about Medium, there we go. That's it. That's it. And yeah, we went through that. Well, there you have it. Okay. I need to take a quick minute break, and I need to come up with a conclusion. Did I miss a first time chat? Who did I miss? Mexit. Oh, damn, Mexit. Sorry, man. How you doing, Mexit? Welcome in. Yeah, I missed that. Okay, so for the people who were here watching the whole thing, wherever you're on, X, YouTube, whatever, help me come up with like how I should close this out, because this is getting turned into a video. I'm going to take a minute and refresh, and then we'll do concluding statements. Throw it in chat. What should I conclude with? I have some ideas, but I need to kind of come up with a few things. So I'll be right back. Okay. Oh no. No. Oh no. I have been informed that Theo might be making a defensive Electron video. I just can't anymore. I just need a farm. I just need to go. I just need to start. I just need to farm. I just can't. I can't. This is terrible. We're ruining the entire industry, and we're ruining programmers, and these are the people that are being followed. This is so bad. I mean, okay, defend Electron, I guess. Sure. Like there's any defense of it, aside from it enabled people to do things that were harder to do. You have to justify every choice you make. Yeah. Hang on, let me finish my coffee. I'll do concluding statements. You're not going to be able to read the post, but it's problematic from the start. Sure, CD, it is. Happy to hear, what you disagree with. Just give me another minute. I'm almost done. I have to refresh my coffee. I need more coffee. Is I think CD is typing. I agree that React took over the web dev zeitgeist for the wrong reasons. It was good at what Facebook needed it to do, and everyone wanted to use it. Likely to get that Facebook money. However, I'm happy to jump on a call too if that's easier. Sure. Sure. You want to do that? CD? Yeah, let's do a call. You can just hit me up on Discord, or you can hop on the you can hop on one of the VC channels on Discord. Completely up to you, CD. Lost the Discord. No problem. Yeah, there you go. Thanks, Lawler. Which VC? Pick anyone you like. Anyone you have access to. It's all good. Whichever one you show up on, I'll jump in on. If you can't access any, just let me know. You're on subs. All right. Okay, so give me a second. I'll join. Okay. Why don't you try saying something first, and I'll see if I can hear you on my end. Hello? Okay. And then what I'll do... Okay, try saying something again. Yeah, hang on. Can still hear you, but I don't think chat can. Let's try that.
How's about now?
Is it too loud, chat? Loud? Alright, let's turn it down.
Uh-oh.
Okay, let's try
Yeah, I'm
that.
not honest. This is better. I got Twitch muted so that I can hear Discord. I don't know if it should be the other way around. So I don't have a streaming setup right now. I just have a mic and a computer.
It's okay. It's all good.
Cool.
Is the volume better? Just one sec, because I did turn it down. I just want to make sure everybody isn't getting ear blasted.
No, makes sense.
Anybody?
I'm gonna assume that it's fine. Perhaps a little bit lower too. I can move my mic a little bit away
No, it's okay.
as well.
I've got volume levels here. Okay.
Oh, okay.
All right. I think we're good
Cool.
now. Okay.
Cool. So, just skimming through the article. So just so everyone has like some background, and I'm not just like seeing like, hey, I'm some a-hole out of the woods.
Mhm.
My name is Charles Villard. I've been a web developer since about 2016, so it's been 8 years now. I've done a fair amount of front end and full stack. I lean front end, and I've worked with Vue and React and Astro on a few projects. And so, looking through this article, what jumps out to me is that it very much misquotes some of the history of React, and I'm not going to pretend like I joined the stream late. I caught the tail end of this, especially a lot of the comments, and reading through some of the description of the article, I'm thinking it's a bit off. It's saying that React was the right solution for Facebook, the same way Hammer is the right tool to drive a screw. And worse than Facebook creating and using React is that soon after it was released, most tech companies around the globe started. This ignores a lot of the history around React, around Facebook's use of it, and kind of throws a lot of throws the baby out with the bathwater in a sense. Now, from what I'm taking away from this is that like this is someone who's been very disgruntled with web development for a long time and maybe just hasn't had a whole lot of experience with JavaScript, or at least maybe they got their start with a language that was not JavaScript. I mean, catch me up, I guess, a little bit.
I mean, they seem to have been around for quite a while. They seem to remember like the older days before a lot of these frameworks. I think they were probably around the jQuery era, if I remember correctly.
Okay. So, I mean, I get from that perspective, I can understand like, hey, all of these frameworks suddenly popping up and everybody needing reactivity in their application and faster interaction times. I think what this is sounding like, at least the portion that I read, to be completely fair, I haven't read the whole article, but the portion that I read, which I'll say is like up to maybe IC dead packages, which is a whole other thing, and I can guess where that goes. But at least with the reason why I'm saying in the chat that it is you know, that it's kind of problematic is that it's jumping to this conclusion that React was built for the sake of being complex, and that it makes you have to write everything asynchronously. No, it doesn't. It's not. That's not what it does at all. It's definitely not async code, but it will update the DOM selectively. Has it grown? Can it grow very complex? Yes, I work at a company that uses React, and we have a very complex React app for our front end, and we're trying to break that down right now. It just feels like this article kind of wants to crap on React for the sake of crapping on React and crapping on JavaScript for the sake of crapping on JavaScript. It talks about its root problems. I'm afraid, at least if the React section is any indication, that it's not really understanding where those problems come from. It just wants to be angry about something that this person wants to be angry about something that that frustrates them, but that maybe doesn't understand the history about it fully.
Okay. Let's assume that that's true. What would convince you to believe that this person is not simply crapping on React for the sake of crapping on React? What would you see that would be like, okay, so he's like he's got into the weeds a bit?
So, okay. So you're saying, like, what do I see in this article so far, or at least in that section?
Well, what would it take for you to kind of like walk back the idea that he's crapping on React for crapping on React?
Okay, sure. So let's see. First of all, the assumption that React is the right solution for Facebook in the same way a hammer is the right tool to drive a screw. That statement is kind of loaded. Facebook didn't invent React to solve all of their problems. It invented React to solve a very specific problem.
Right. Hang on. What I'm asking is not what you found problematic in the article.
Excuse me.
What would it take for you to see in the article that would make you think that this person is not crapping on React?
Excuse me. Okay. So I would need to see some kind of nuanced understanding of how React works, what React does. From the description of it, he's making claims that everything should be asynchronous to avoid locking the UI. Okay. At the same time, maybe he doesn't mean asynchronous coding, right? Maybe he's not confusing async await with locking of the UI. However, given certain applications these days, like, you don't want to make an update to something and then have that lock the entire UI from working. It's not for every website, no, but if you're working with something that is real-time data, I don't want my JavaScript blocking, because JavaScript is, single-threaded. It will block if something gets changed. So I need something like React, something that can handle reactive updating of the DOM.
Okay. So what would be a consequence of that blocking paradigm, where if you change this one thing, everything else is blocked? What would you say a consequence of that is?
Consequence of that is going to be having to wait for everything else to update. Now, sure, someone can probably wait a few seconds for something to update, but the front end, our goal as developers is to make sure that is basically user experience, right? And speaking as a front end developer, like, my goal is to make sure that if I'm building a tool that I want you to use, you are not, discouraged from using it. You're able to be as effective and as efficient and as productive in that tool as possible.
Okay.
Yeah.
Okay. Yeah.
So the way I see it, like, you don't want to have, say you have some complex application, you're updating stuff real time. You don't necessarily want a React component, or any component really, to have to wait for the event loop
Okay.
to fire off.
Okay.
Now I see that you're pointing out like the Jeremy Wagner article, and true. I haven't read that article. I don't know what that is. Where is that is that in the React section or is that elsewhere?
It's a reference in the Medium article, and then it goes off to that Wagner article where he breaks down how React works against Preact versus Vanilla.js in terms of loading time and operational time to do something simple like an event listener.
Yeah, no, that's fair. I have no qualms about React not being the most performant framework. But that was something else that I took umbrage with, was that all of this seems to stem from React, right? And in the section that I read through, it highlights primarily React. Where did I see this? Geez. My ADHD is kicking in a bit, but
No,
I
it's
did
okay.
see that. I did see that with I understand like that React is not the most performant framework, and this is not in defense of React so much as is in defense of it's more so my statement is like whether this article is 100% credible. Again, I would have to read the whole thing, but I take some concern with it given the immediate choice to look at React and say this is the proof that everything is terrible, right? React taking over was sort of a reaction by industry. So I don't think crapping on all of particular web technology is the answer there, if that makes sense.
So would you say, are you considering like crapping on all of the web technologies, like also crapping on JavaScript, just vanilla JavaScript?
I mean, again, I haven't read the whole article, but I was just stating that this kind of this gave me some pause when he immediately jumped to Facebook built the thing because there was no other way to do it. Like they built what they could build for the iPhone at the time, so that experience specifically would be faster. And then other teams decided to leverage that, and people, wanted Facebook money.
Mm-hmm.
So they wanted to learn React, and other companies wanted to have, similar fast experiences, and that was the buzzword. I've seen that kind of across front-end development, where if people start using tools and are successful with those tools, their higher ups tend to start looking for people who know those tools.
Mm-hmm. Mm-hmm. Okay. So if then I guess I could say if it's true that just because React did this thing doesn't mean that they came out of like paved with bad intentions kind of a thing. That's fine. Can you point to something that was, so let's not take React then. Let's do anything else that was born out of a similar kind of like a contextual premise and had long-term positive impacts.
So, okay, that's a little hard to. That is a little bit hard for me to answer, like right off the cuff.
Mm-hmm.
You're saying you want an example of something that was built with a similar thing approach for React, right? Had similar requirements, had similar constraints, had longer term, had overall positive benefits to the industry.
Yeah.
I think that's not quite a fair request, because Vue was built, for example, if I remember correctly, sort of as a reaction to some other hobby projects, right? Mm-hmm. Angular, at least early Angular, predated, if I remember correctly, predated React.
I think it did. Yeah, I think you're right.
Yeah, and that sort of started the popularization of the use of these sorts of frameworks. I mean, I don't see it as any of these as a net benefit or a net negative necessarily. My reaction to this is primarily that like he's immediately out the gate with, you know, a very sour reaction
Mhm.
to JavaScript and to
Mhm.
the use of frameworks. I mean, and to you know, to be transparent, I have a bias because I came in post jQuery. I did use jQuery.
Yeah.
I didn't build it with you know, anything else but I haven't really built websites without a framework per se. But I think this is very kind of, I feel like he's swinging at this with a huge bias towards the idea of a framework. I'm not saying that all frameworks are, you know, perfect examples of progress necessarily. I agree, like we have gone very JavaScript heavy,
Mhm.
but at the same time, I don't know that this is something that I would say, hey, you know, you're right. Like maybe I'm stepping on my toes a little bit here. But yeah, I think there's a little, I think there's a little too much subjective like hate for JavaScript in this.
Okay.
I don't know. I feel like it kind of misses some nuance in, at least from what I scanned. And again, I'm defending something that I've only scanned for a little bit. So
Yeah, I won't hold your feet to the fire too bad on this. But then so one of the things that you're worried about here is the bias in the initial opener of the article, which is like this person seems to just have a complete hard on for you know, hating on React or things like React. I'm gonna push that right back on you. No, maybe not as maybe not in the same way, but in a different way. Because I think what you said was, I don't really have a lot of experience outside of frameworks. Is that accurate?
So I'll say this: when I came into web development, React was starting to get into its swing. Angular was just facing its 2.0 phase, right?
Mm-hmm.
Frameworks were the tool that everyone encouraged newer developers to learn.
Mm-hmm.
I did build websites with WordPress. I have built websites and applications using .NET Web Forms. You know, I've used and debugged jQuery. You know, I wasn't around necessarily for the days where you had to use GIFs for image borders, but I'm familiar enough with how that worked and the histories behind it to have seen like where this kind of goes, and some of the things here, just to say, hey, this was invented to fix this or fix that or fix the other. Right? Like, even, you know, I'm staring at this first image here. HTML invented, CSS invented to fix HTML. I get that that's a Fireship joke, but I know that there are a lot of people who have that actual sentiment, right? Like, oh, this was invented to fix this and fix that and fix the other, and it's like, progress is messy. Progress in anything is messy. So I still think it's weird to just jump into this and say, hey, all web crap, you know, all web crap is crap, right? Like all development stuff is crap. It just kind of throws me off.
Okay, but I just want to be clear again.
Maybe I didn't. Did I answer the question even? I'm starting to wonder if I didn't.
I think you kind of did. But I want to be like clear about it. You, outside of frameworks or libraries or an abstraction over a layer that may or may not have been necessary, your typical experience has been in some form of like a common abstraction that like many people used. So like WordPress you gave as an example, jQuery would be another one, React, things like this, right? Okay. So my argument back would be that irrespective of whether history was correct or not, or whether it was being memed or joked about or not, then you also have a bias in that you haven't even attempted to do anything outside of these things. Or maybe you have attempted, but it doesn't sound like you've like, just going based completely on what I'm hearing from you. You haven't worked outside of these things. At least not enough. Let's be charitable. So maybe like not enough for you to have a non-bias, or to negate a bias based on the experience you've only had, right? And so if that holds true, then the argument that this person has a bias or you have a bias, they kind of like negate each other. And then what you have to do is go drop down into the actual arguments.
So I'll say this. I have done some work where my goal is just to return HTML, where I didn't feel there was any need for interactivity or reactivity, right? If the goal is simply to build something that doesn't even need a website, like I have done some work in the past where it was just build a CLI to solve the problem.
Okay.
But ultimately, what I see modern web development as is it's additional tools to solve that problem. Now, I think, yes, again, I agree that we've overcorrected with how much React we ship, how much JavaScript we ship for the sake of building a website, right? In at least, for what this is worth, between the meta frameworks of today, I choose Astro for a very specific reason, right? There is not a whole lot you can do in Astro, or that other frameworks, meta frameworks can do that Astro can't do without JavaScript, right? Like you don't have to ship that JavaScript. The Islands architecture is very compelling to me for that reason. And so the way I see it, like, these are all tools. Now, depending on what problems one has to solve, you can reach for these tools or not. So I think, again, you're not wrong. There are a lot of times where, I definitely have a bias here, and I think there are a lot of times where, like, the reliance on JavaScript is like, hey, we're going to build a new website, reach for some JavaScript something or other. It's too much. At the same time, I myself have been working in enterprise environment for a long time, for a few years now, actually. And when you need to build something, and you want to do it without having to pay an arm and a leg, what you're going to find is companies, because we're talking about this like sort of in the silo of just building things, right? Let's give it some context, because companies are going to pay the bills for engineers most of the time. If someone is going to build a project, or a company wants somebody to build a project, they're going to look for who is most plentiful, most available with the tools that they can figure out they need for that project, right?
Yeah, makes sense. Yeah.
So JavaScript developers, they're there, and they're pretty plentiful at this point.
Yeah.
We're an unfortunate pox upon the world, I admit.
Okay.
So
yeah, no, I agree. Okay, so I'm gonna kind of go back just a little bit, and then we'll move forward, because I think you brought up a few points here, so I'll try and I'll try and tackle them. So if you said that there was one project, whether personal or professional, and you essentially had to like ship some HTML to the browser, more or less. Is that right?
Yeah,
Okay.
I've had a few projects where it was just sort of deploy a build, and then that build will get an API call. We'll get a request, and it will generate HTML and just send it, and there's no reactivity or anything.
Yeah. Okay. So what did you use to do that?
That was .NET Web Forms primarily.
Why did you do that? Why did you choose that?
Because I was hired to do it. I was hired and paid to use that.
Okay, so somebody else made that choice, essentially, that you're going to do it that way, and so it just was what it is. Yeah.
Here, a more recent example. I built a static website for a company, for a guy who's selling seminars, and so I used Astro, and there is no reactive anything in there.
Okay. Why Astro?
Astro because it would do exactly what I needed to do, and it didn't need to ship anything interactive. It didn't need to ship anything reactive. It didn't have to ship anything with WebSockets. It was just a static website.
Mm-hmm. Okay, so then maybe you haven't done something that's completely outside of a library framework or something like that, but it sounds like you have done some things that kind of like they're in that direction. So Astro, the example you just gave, Astro would be
So
one of
here,
those
let me
things.
ask you this. Let me actually ask you this.
Sure.
What do you mean by outside of a library or framework?
Like, you don't need Astro, for example. It would be like, yeah, you literally
So
use,
just writing HTML, CSS, and JavaScript?
and then if you need to ship it out of a server, then you use something like it could be PHP or something, and that's it.
Okay, so then what's the argument exactly here? Because if I'm writing HTML, CSS, and JavaScript, those are all abstractions in a sense. Well, no, those are all base tools for web. And then as soon as I use PHP, I'm using an abstraction.
What is the
If I write my own
abstraction?
I'm using PHP to serve it. Am I not?
Yeah, what is the abstraction portion of PHP? Like, what is it abstracting?
If I remember, like no, okay, I see what you're saying. So PHP to run the server, right?
Yeah.
To run the Nginx server.
Yeah.
Technically, Patroclus is right. Yeah, it's an abstraction over C, sure.
Yeah, I mean, but then everything is, right? So if everything is an abstraction over C, then nothing is an abstraction over C. Like, it's that's a stupid way to say it, but yeah.
I agree. Yeah. That I get. So, I mean, I haven't done raw PHP. I haven't like raw dog PHP to write a server. Yes, that is true. I'll cop to that. I haven't done raw Ruby to write a server, but at the same time, I think we're at a point now where there are reasons for that.
Okay.
Right. By the time you get to that argument, like by the time you get down to it, like you're writing your own servers, which is a great practice.
Right.
But there's a reason for those abstractions, and it's because enough people have done that practice to know, or to have at least a really good idea, like, well, these are the reasons why we shouldn't at that point. No?
These are the reasons why we shouldn't write our own, and we should instead use an abstraction. Yeah? Is that what you're saying?
Yeah. Like, basically, yeah. People have identified and researched enough best practices that we have abstractions. Like, that's why you have certain libraries in across any language that abstract the server experience.
Okay.
So Lafoli, you're saying that I'm, because again, I didn't catch the whole thing, and I'm kind of.
No, it's fine. Yeah.
No,
Yeah. No.
I already identified the problem, so I'll tell you what it is because you're too dumb to know.
Well, so hang on. I'll rephrase the question because I had this question locked and loaded. Laugh is running ahead of me here because he knows where I'm at. So then here would be my counter question. So I would agree that there are cases where abstractions are not just for funsies. They're extremely useful, like 100%. Oh, it's okay, Laugh. You're good, man. You're way ahead of us in the convo. You're too smart. Yeah. Okay, so like it's not that I would be for zero abstractions, because then at that point my argument reduces to why not just write assembly, and it's like, okay, do we really want to go back? Like I get it, I get the argument here. There, it's fine. That's not really what I'm calling for, but it would be my rephrasing of Laugh's exact question here, because he's thought ahead of me. Is this? Your statement is, well, somebody has come up with an abstraction that has solved a problem that you're going to want to have solved. And so you can make a general statement about the problem, something like, well, we need something that serves HTML from a server. That's a problem. You want to have that solved. What are you going to do, bro? Are you going to go write your own server engine every single time you're writing a new website and you get a new contract or whatever? Of course not. There's going to be some level of repetitive code, things like this, that, you know, the same concepts and paradigms. That's of course going to get abstracted away. Somebody else has already figured it out because they ran into this problem before you did, and therefore their abstraction is a reasonable thing to reach out for because it solves the problem that you're looking to solve. However, my question back would be, that's all fine. But if you have never even attempted to solve that problem, upon what basis can you make the judgment call that that abstraction is appropriate in the first place or not? And you cannot appeal to authority because that is a fallacious argument. Because then by that mechanism, anybody with the right qualifications could make the stupidest abstraction on the planet that doesn't make the abstraction good.
No, okay, I get that. And I know that I can see where, you know, saying something like, oh, most people, like people, a majority of people or the community will decide whether or not it's good. Like I can see why that would also probably be not a great argument, right?
Ad populum argument, yeah.
Yeah, exactly. So the way I see it, for the most part, people are reaching for, at this point, what they know will work, right?
How do they know? How do they know it will work?
Well, from it is an ad populum argument, yeah, but effectively it is like effectively they've seen proof in the pudding. React became popular because Facebook showed what it can do.
Appeal to authority.
Exactly. Okay, fine.
So,
but here's the thing. Okay, so you're saying it's an appeal to authority to trust Facebook with, you know, what they did with React, what the React team did to develop React. All right.
Yeah.
If it's constant appeal to authority to trust a team and a community saying, "Hey, we've experienced this. This is good. Let us show you this. Try it out for yourself." Right. Then at what point do you decide whether or not an abstraction is, you know, worth it without additional proof?
Okay.
Like where do you get your proof that that abstraction works and is better than, like, you just test it out yourself, you write it out yourself, but okay, we could do that. And if you are working on for a client or towards a deadline, then, you know, you are going to spend that time trying to build your own first. It doesn't make much financial sense. The incentive there is you get to experience building out a framework yet again, or you know, per project or something. So you know, that's why most people will reach for React.
Yeah. Okay.
Or for something that, or some kind of framework that abstracts this away already. You're right that, you know, sure, I understand, like you trust somebody else who's built something just because they say, hey, that's dumb, but at the same time you have to understand the incentive, what the incentives are,
right,
in a given situation.
Okay. Yeah. No, I agree. I agree with you. Here's the problem where I think that there's a miscommunication that happens, and I'm trying to figure out a way to communicate this more clearly. Because I think what happens in your argument, to me, which is not like a bad, it's and you're actually describing the situation. So you're making a descriptive claim about like what is, and it's not it is what it is. Like you're right. There's like financial incentives. What are you going to do? Are you going to like write these things on your own? You know, how are you going to tackle the time and money involved in doing that? That's not actually a bad thing, but it goes over what I'm actually trying to say. And I mean that in like, it's my fault. It's not yours. It's something I'm trying to work out. So what I'm trying to say is that even though you're making a descriptive a claim, more or less a descriptive claim with some, you know, nuance there, I'm making an ought claim, which is a prescriptive claim. So instead of internalizing, well, this is the way things are, and therefore I as an individual would be incumbent on me to take on a huge amount of financial burden, time burden, etc., all these burdens just on my own to go and try and learn these things, and do it myself. How can you expect me to wade through the entire ocean of programmers and companies and whatnot who default to these other mechanisms? How can you expect me to take on that responsibility? That's fair, but that's not what I'm actually saying. If it were the case, prescriptively, that most programmers should take on more responsibility for doing these things, then that argument that it's only on you is no longer valid. It is now shared responsibility. And if more programmers were being told, hey, it's okay for you to question whether or not Facebook's way of doing things was correct or not, whether or not the, that big team that built this successful website with millions of dollars and used this framework, whether that's the correct framework for you to use. If there was an entire, at least like a more than a 50% shift in people's brains in the programming space, at least, if not further than that, to be able to dig into these things and actually feel okay and acceptable to be like, how am I supposed to judge these things? Well, I guess I better go freaking figure it out because that's my job. Then it's no longer just about an internalized you in an ocean of everybody's doing something else. How the hell am I going to compete? It's now you and many other people, which then helps push the pendulum forward. And I'm having a hard time explaining it even now. But does that kind of make sense?
So no, I see what you're prescribing here. I see what you're saying, that more people should be more curious. In short, people should be more curious in building their in trying to understand how frameworks work and how they can build this for themselves.
Right.
Now, what I don't take umbrage with that. I think that'd be really, fantastic and great, and kind of a kumbaya kind of way. It's like, let's all learn, this stuff and definitely, iron out the kinks. But I think it also sort of, we kind of see what that looks like already, right?
Okay.
I mean, we see that with Preact. We see that with Vue. We see that with all of the new frameworks. Like, these are all people who see React and go, okay, we could do better.
Right. Except my counter argument would be that the answer to an abstraction is an abstraction that is simply just a lesser abstraction, but an abstraction nonetheless.
But then why? But here's so here, you said not so long ago, you said that at some points an abstraction is fine, right? Abstracting the web engine. No, it's not no. I'm not saying it's okay to question as long as you toe the line. That's far from what I'm saying.
I don't think CD's saying that, to be fair. I don't think so.
That's not what I'm saying. Yeah. What I'm saying, I'm trying to understand, like, why React is so maligned as, like, I understand some of why React is so maligned as an abstraction. I understand why JavaScript frameworks are so maligned as an abstraction. I don't think that they're poor abstractions. I think they are abstractions that have gone too far. I think they're abstractions that have been leveraged too much. We've swung this whole way when we discovered, oh, you can make this abstraction to do these things, right? And I think people got super excited about the shiny and new, in combination with, oh, the industry will pay this much if I just know how to spell the word, right?
Yeah.
We're seeing sort of like a reaction. We've seen a reaction to that, in HTMX and Go, right? We've seen a reaction to that in more back-end tools now, trying to catch up to the same sort of DevX to make that more, make that easier. I think it's much more complicated. Ultimately, I think it's much more complicated than just React was made and is all bad.
Okay, that's fair. But again, it comes back to, would you trust the person who created Preact to have an objective value judgment metric against what it would take for them to value judge whether Preact was necessary or not?
based on
The fact that they built Preact.
no,
How-
I mean, I would base it on their given reasons and what they have accomplished with building it.
Right. So if the how can people who live in only abstraction land and only that value judge the abstraction?
So, okay, I won't say that we've already
It doesn't.
established that I
It's a
haven't
general
lived in
you. I'm talking general, like
No, I
generalized.
understand. I understand. I understand. But I'm just using my perspective,
Mm.
right? I think yes, like I said, like I think we're on the same page here. Maybe we're just like passing, like we're swinging past each other, like just a little bit here, because it's like how do people who've only learned from abstractions? I'm trying to make sure I get the question right.
Yeah.
How do people who've only learned from abstractions know when an abstraction is worth it? I mean, even if you've only worked in abstractions, you can understand what values other abstractions can provide, right? If
Okay.
you have a baseline abstraction
Mm.
that you're familiar with and you see that, oh, this abstraction minimizes my load time, it makes my job easier, it makes this readable. There are a number of metrics that person can use to judge whether or not that abstraction is worth it to use for them,
Mm-hmm.
right? Or for their project. Here I have actually a really good example of this. In my work, I work with web components, custom HTML5 custom elements.
Nice.
And I use a library that Microsoft has produced called Microsoft Fast.
I've heard
It
of this.
uses an Angular like syntax.
Yeah.
I had a team approach me to add a component to this header that I work on that's built in using Microsoft Fast.
Yeah.
And I gave them two options. You can either build it directly into the header,
Mhm.
or you build it outside of the header and inject it in using JavaScript.
Right.
They decided to build it in React because they were familiar with that syntax. There's no performance. Like, I would argue dollars to donuts if I built the same component in React and in custom elements. Like, the custom elements would win out probably for speed.
Right.
But the team chose to do React because that's what they were familiar with. They weren't familiar with any kind of Angular like syntax. They weren't familiar with custom elements. And now I'm looking for a different abstraction so that I can include other people.
Right. Okay.
Right.
Yep.
So
you've described essentially a way to do. You answered exactly my question. Is like, how do you value judge an abstraction when the only thing you know is an abstraction? And you answered that. It's like, well, you can judge abstractions between each other, and so you can say like, well, I understand abstractions to a certain degree because I use them all the time. And I can understand when one abstraction is better or worse than another for, whatever intended purpose I want to use it for. So far, so good?
Mm-hmm.
Okay. Now tell me, now that we've covered that, now tell me how you value judge no abstraction versus abstraction if the only thing you've done is abstractions.
No, at that point, yeah, we're going back to, somebody who has to do the research. That we're going back to that to being curious and encouraging that curiosity. I've never disagreed with that.
Okay.
Now somebody has to actually do the legwork and understand, okay, how do we accomplish this without any abstractions in our given environment?
Right. So like, generally speaking, you're right. We agree. I think we do agree. The problem is in the prescription. And that's what I'm trying to kind of like hone in on, and because it's on me, I'm making the assertion and the claim that, like React is the worst offender and things like this, and why. And so it leads to the prescription of essentially what we're talking about, right? And so when you look at something like, this is why I like this article, because what this guy Wagner did is when he looked at performance tests, and the article itself goes into like a lot. Like he picked like 5 different types of devices, and mean, median, average, max, and then React, Preact, and with just vanilla. And this is the kind of stuff that more people need to be doing, because then he could demonstrate that React is on average 24 times slower than vanilla JavaScript, right? And that is an actual abstraction versus no abstraction value judgment because he went and did it. And if more programmers did this, it's what I'm trying to explain, and I think I've done a poor job of this for like a year and some odd months that I've been trying. If more programmers did this, then what you would end up with is, instead of looking at it from an internalized, okay, but if I have to do it, this is crazy, look at how everything is. But if more programmers did it, then what you start doing is you start pushing back against these kinds of paradigms, and you start being able to spread around the capability of value judging whether an abstraction is worth it over no abstraction. And that necessarily means that just in the same way as a business looks at, well, who can I hire? And all the developers go, React. You can hire React people and they're cheap. You can push that pendulum the other way and go, actually, you don't need React. We have plenty of like no abstraction land here, and it's people are very you can pluck from a huge array of knowledgeable people to come in. Yeah, maybe you have to pay them a little more, but your team size could be smaller. The end result is more efficient. Users are happier. Everybody makes more money, right? Like the point isn't the point I'm trying to make is that it's not about like you as an individual, like, oh, that's it. It's your fault and you're responsible. It's that it's a mindset that needs to be drilled back into the tech industry, that like, it's okay to say, why the hell are we doing this? Let me go and figure some of this out so you can make better value judgments, because the alternative is where we are now. Nobody's happy with it, and nobody can look outside of an abstraction value to see whether they're even in a bad abstraction to begin with.
Okay. So I can jive with that argument. I can understand, why you want to make this more. I can see why you would want this to get more eyeballs, right? Because I understand the whole argument that you want people to be able to say, no, we don't necessarily need React for this because A, B, and C. You're not wrong. I think though there are two things. Well, okay, maybe this is honing in on the wrong thing, but what you said about Jeremy Wagner's article, you said that he tested this across React and just regular vanilla JavaScript across multiple devices, across multiple paradigms, right?
Yeah.
Okay. Most people, So part of me wants to say that, wants to point out, most people won't do that. Most people won't touch more than one or two concerns.
Sure. Yeah.
But that's actually neither here nor there. I think you're not wrong. I think it would definitely be a overall benefit. I think you've won me over with that. To have people actually learn to be curious and learn not to lean on abstractions. I think the other part of it though is how many people realistically are looking at newer projects.
Mm-hmm.
How many people are solving sorry, 1 second. Yeah. I actually have to get going soon. Sorry.
No, that's fine. Yeah. Tell me when you got to jump. No problem.
Yeah. I gotta be maybe like 1 more minute and then I gotta go.
Okay.
But ultimately people these days, that also necessitates the opportunities to do that. Not everyone gets those opportunities, and oftentimes the reason why we see such a prevalence in React is because most roles you're coming into a company you're coming into a project that will necessitate that from jump, right? They're working with brownfield stuff. They're working with legacy projects,
right?
And they want something that that they can build. I will say that there are some interesting abstractions. They're not abstractions, but there are some interesting projects out there that don't rely on abstractions. I remember interviewing, I think it was for some magazine company, I think it was like Dotdash Meredith. They were looking for full stack and front end engineers.
Mm-hmm.
Their whole stack was using primarily Java and Twig, and then they recently started using Vue.js because they found a reason to.
Right.
And they would not. They were not interested in any arguments about using anything else. If you were asked about it, it's like, well, you're going to have to prove that out with our principal engineer.
Right.
So I don't think that it's totally lost, that art.
It's not, no. And I think articles like this prove it. And I would say again that you are very accurately describing again what is, which is like the reality of things. And what I'm trying to communicate and failing to do so is that my prescriptive claim can lead to an adjustment in the descriptive claim. Current descriptive claim does not have to be current descriptive claim. If more people picked up the prescriptive claim, we can make a change to that. But it's been hard, very difficult for me to communicate that.
I don't think the issue is necessarily communicating it. I think like you can sum it up pretty easily. People should be more curious and should test their abstractions.
Yeah.
People should try things outside of that box to solve the problem. I think the issue is showing how. I think the issue right now is like simplifying that in a world where basically the goal of any project is increase shareholder value.
Right. How do you fight the pressures that are making it difficult to do that? Yeah.
Exactly.
Yeah.
The incentives right now are wrong on many degrees.
Right.
So I think you're fighting the good fight. You won me over with that argument. And I actually got to get going.
Yeah, no problem. Thank you, man.
I'll try and give this more of a read. I don't know how interesting this all was. It actually went longer than I meant it to.
No problem.
This was an interesting talk.
Yeah, no problem. And feel free to throw ideas. I mean, any ideas you have, I would love to listen to anything you have, because I am trying to work this out too. But I appreciate it, CD man. Thank you.
Yeah, no problem.
Okay.
Have a good one, man.
You too. Bye.
Bye.
Okay, that was good. Let me disconnect here. Discord. Off. There we go. Hey ALS. Hey Mist. How you guys doing? I don't have the Goomba hat. Now this is where we go. What an a-hole. Yeah. Friggin' CD. Can someone ban CD, please? No, don't do that. Don't do that. No. Don't ban CD. Don't ban him. Yeah, I don't have the Goomba hat near me. I'm sorry, ALS. I have it all the way out there. Thanks, CD. I appreciate it. Go do your thing. Okay, so that was good. Like, I think CD gave. I think this is the problem, right? Like that conversation, it wasn't even an argument. Like, we didn't really argue. We just like lightly disagreed. It was like lightly salted disagreement. I think this is the actual problem here is, and kind of to what Laugh was saying, right? Like, Laugh is not entirely wrong with what. Hey, Vincent, good to see you, man. I saw your message earlier. I'm sorry I was talking, but good to see you back. I know it's been a while, Vincent. I hope you're doing well, man. Vincent, I think you're like, dude, I think you're one of the first people that was ever on my stream, if I remember right. There you go. You're VIP now, Vincent. I think you've been here from the start, man. Anyway. So the thing that I'm trying to communicate is that it's really easy to look at how things are and go, well, currently how things are makes it near impossible to escape how things are, right? It makes it near impossible to look at something like this, like an article like this, and agree or disagree, but agree with like necessary parts of it or important aspects of it and go, yeah, okay, React wasn't the best thing in the world. We probably, maybe we shouldn't be using it as much or maybe at all, like whatever conclusion you come up with, right? And you go, yeah, okay. And then you have to go, all right, well, now what am I going to do? Like, what am I actually going to do in real life to implement the thing that I know is not, optimal in this in the current landscape I'm in. And that's where the rubber meets the road, because now you're talking about what CD brought up, which is like, You have financial incentives. Everybody needs to get hired. Everybody needs to make that paycheck in order to pay the bills for their family. You want to work within a team, and so this is the stuff you have to work with. Decisions are made outside of your purview. You don't have an impact on certain decisions. These are all things that are like immediate roadblocks to, well, I kind of agree with an article like this. I kind of agree that we've gone too far on this side or that side, but what am I actually going to do? And it's fine for me to sit back and go, well, prescriptively, like here's what we should be doing, which is we should be digging into different ways, non-abstracted ways, so that we learn, we have better understanding of fundamentals, right? But in practice, that can be a difficult thing. How could you actually do that? I think the unfortunate answer is that the cycle has to break somewhere. And if you're waiting on businesses and executives and leadership to break that cycle, you're barking up the wrong tree. If you're waiting for your team lead or the principal engineer or the CEO or the CTO or an entire company to go, yeah, maybe this wasn't so good. Maybe we need to invest some money in a different way. That's not going to happen, at least not anytime soon. There is a way it will happen, and that is if consumers complained enough with their wallets or by vocalizing their complaints about the performance and degradation of the things that they're using. But that's also not going to happen because we have beaten consumers over the head and essentially desensitized them to accepting and being okay with the way things are. Did my mobile app crash? Just is what it is, man. It's just normal. It happens to everyone all the time, every day. Is this website taking a hot minute to load? That's every website now. It just is. That's the way the tech is. Does it take 6 years for me to download a DLC for a video game? It's just the way it is. That one might be less of a good example, but still, the principle here I hope is getting across. Consumers no longer complain because they just are told, oh, this is the way things are. And to some degree, things like AI and things like React and all these abstractions give companies an excuse to respond with, yeah, this is the way things are. And consumers go, well, I guess this is the way things are. So you cannot count on financial incentives to change. You cannot count on people to, executives and companies to change course. Someone along the way has to say, okay, this is enough. We need to make a change. And unfortunately, it's on programmers' shoulders, but not any individual programmer, right? So it might seem a lot for one of you to go, geez, what do you want me to do, Spiro? You want me to go and tell off my team and say you guys are stupid. Why are you using this abstraction? And then what? And then I have to go and prove that I have a better approach to this abstraction? You're crazy. Maybe that would work. Maybe in my scenario, but everyone else is going to do whatever they're going to do. How am I supposed to fight this? That's not the actual problem. The problem is that nobody is that most, well, maybe not nobody, but most, a vast majority of the industry seems perfectly fine to go along with this. Some for good reasons, some for not good reasons, but it doesn't matter. It takes many of us to start going, well, if I actually want this to change, then I have to go look into this. That means that you're going to have to take some time outside of your normal schedule, and you're going to have to go, what would it look like if I questioned the entire status quo? And that might seem like a daunting task, but the point is not that you have to complete that task. The point is that you have to look into it and get to a certain point where you feel like I've done enough to understand and make better value judgments as to whether or not something is good or bad. And then I can find a way to communicate that to colleagues, to leadership, to executives, etc. Everything starts with you have to build up that knowledge. And right now, yeah, descriptively, there are a lot of roadblocks to you having enough time to build up that knowledge, but it's got to start somewhere. What's up, Laugh? What's your example? Hit me. Let's see what Laugh comes up with here. Hang on a sec. Damn it. Damn it, Laugh. Holding the stream hostage. So this site is an alternative to GitHub for open source only, right? Pay attention to two things, okay? One, how fast it loads, how responsive it is, okay? And two, the languages used in the bar at the top. All right. I think we're going to get a hot link dropped. This is the repo for the site itself. Codeberg infrastructure, Forge JO. All right. Here, what I'll do is I'll put you down here. And then we'll go. Okay. Forge JO. The code deployed to Codeberg. I mean, it loaded really fast. Yeah, it loaded instantly. So I'm curious. Let's go into the inspector tools and just have a look at that. It might not come across perfectly on stream, but let's just have a look at this. So I disabled the cache on purpose, right? Just to see what it does, but I don't think I have throttling on. Every page loads instantly. It is written predominantly in Go, so they actually wrote their own web server and did that whole thing. Okay. Look at the amount of assets. I just want to pull this up. Look at the amount of assets here for approximately 2 megs, right? Let's just run it one more time. Okay, 36 requests, about 2 megs, 762 milliseconds. Okay, that's fine. And for about the same number of resources, look at the number of assets. 10 requests, 1.5 seconds. And it doesn't do the stupid crap that the React website does, where every hover over a thing, it generates another request. Okay, so yeah, so to Laugh's point, say what you will, perhaps, about the way that maybe it looks or the functionality. I mean, let's just, you know what? Let's just do something here. Let's open one up. What does that look like? So here we go. It looks very similar to GitHub. Has a lot of GitHub-like features. You can do the raw. You can edit it if you are the repository owner. There's an RSS feed. Yeah, I'll put this over here. Let's have a look here. Okay, add a few improvements to the footer. Yep. Okay, is highlighting on source files. Yeah, there you go. You can do that. Yeah, it's all here. I mean, it's all here. So this is the React version, right? We've all seen this 100 times because I keep showing it. How about the GitHub version? Let's go here. Let's do I like a little bit better. I don't want to compare changes. How do I? Spinning loading bars already, yeah. Holy crap, it's actually hanging. Okay, there we go. So I'm gonna do the exact same thing. I'm gonna open up the thing here. I'm gonna go like this. Okay. And then we're going to have a look. So 8 megs, 2 transferred, 165 different resources, chunking and vendoring and all that stuff. All right. And then if we open up, let's open up gitignore, just like what they had. It's another 14 megs with 4 megs transferred, 260 requests for opening up a file. And each time you highlight, there's a request being made. And then let me go have a look here. Is it okay? So it's pulling the favicon. I mean, that's a fail. But that's an easy fix. And the resources to load this page, another gitignore to a gitignore, is orders of magnitude less. I mean, 14 megs for this. What exactly is running on here? Who the hell knows? I know they have Copilot here, so that's at least part of it. And then I'm curious. Let's go pull in a PR with like a lot of comments. Okay, so here's an issue with a lot of comments. Go down, go do this. Yeah, let me just refresh one more time, just to kind of get a baseline. Loading bars, yeah, it was okay in terms of speed. Let me go over here. Wait, why are you doing this? Go back, go to issues. Oh, it's a different thing. Got it. That's fine. Let's pull here, 9. Okay, and then we're gonna go look at this. 9 comments, 1.3 transferred, 2.6, 1.4 seconds with 20 requests. 5 seconds with 131 requests. And the only thing that loads are the avatar images. Let's just do it one more time just to be sure. Yeah. Now, even if your argument is okay, sure. They seem to load at comparative speeds, although this one is definitely slower, especially if you look at the finish line. What would be the problem? And this one has more functionality in it. The point here is that you can do a lot more with a lot less. That's the point. And that it does not take a massive library or framework to do something as complicated as what's happening with GitHub. Look at how little is loaded and how quickly you get to the finish line to view code in a GitHub style thing. Right, so that's a good one. That's a good one, Laugh. Okay, so I need to come up with some concluding statements. Yeah, it is a good site. Yeah, I have to come up with some concluding statements, and then I have to end the stream. Unfortunately, got work to do. And boring refactoring of the ship chess game. So I'm trying to think, like, how could I end a video? We went over the state of, okay, we went over AI being built into NVIDIA stuff. 5% JS, by the way, yeah. We went over why those kinds of practices neuter the ability to do optimizations or push the boundary forward. We went over Thread Interactive's video on what you can do with a lot less hardware and older games. We went over a React rant article and why it's at bare minimum vastly overused, along with metrics. Like an actual case study. We read comments on that article with people with differing opinions on it. We talked with CD. Okay, I probably don't need to say much to close out. I can probably just recap. As I'm not a front-end engineer, I don't build websites much, but I made one not that long ago to learn React. I'd be interested in what you think. It's kind of satire, cred maxing. Let me see. Making the art of living beyond your dreams. Let's just have a look here. Let's roast you a little bit. I mean, it's not terrible. You probably learned a few things doing it this way. Yeah. I mean, that's not bad. So here's what I would say then, Vincent. Why don't you try making this in vanilla without React and see what you learn out of it? Now that you know like the problem spaces and the business logic, try vanilla. You're going to learn like a lot doing this in vanilla. You will. This is definitely like one of the better React sites at first glance that I've seen. You don't have a lot going on here. It's good. It's a good thing. Now let me get the Twitch ads over with, and then I'll do a conclusion. Anyway, I hope everyone's doing well. Thanks. I might try it, but not in the near future. Keep in mind, design chips, so this isn't really my space. Yeah, well, that's kind of, at the very least, someone like you would have a better awareness of like the consequences of the way you're building things, and you know what the consequences are on hardware, right? Like what actually happens on the hardware to execute these things, right? That's a pretty good place to be. That's a lot better than most people, including myself. Shut up, laugh. Stupid dad jokes. Freaking dad joking us. Okay, I'm going to keep that in the back pocket. And then I'm going to let the Twitch ads play out, and then I'll do some stupid, simple concluding thing, and then I'll call it. Chips and socks. It's a weird factory. Yeah. $30 on the Twitch ad side. I know not all of you get the Twitch ads, but that's what Twitch tells me, so I'm just going with it. Okay, I think I'm ready. Twitch ads are done. Okay, well, today we went over how AI is being implemented inside of, at the very least, NVIDIA, along with the hardware they have in order to render more frames to you, which is supposedly supposed to make video games better for you and a better experience. We went over why that's not necessarily the case and why these things, why these kinds of practices neuter the ability for the industry to find new ways, novel ways of doing things when you can just slough it off to AI. We went over the Thread Interactive video about how we could do a lot more with a lot less, even historically. We went over the article with regards to React and why it should not be something that you should just default reach out for without some consideration, and some metrics on an actual case study around using React versus not using React and the performance differences. We talked about whether or not you're capable of even making a value judgment of any level of abstraction if the only thing you ever do is work in abstractions. We went over how difficult that can be, because in this landscape, you're just like essentially told and incentivized to kind of turn off your brain, just use this thing, somebody smarter than you built it, or here's some money for you to just go along with this. And these are bad practices as well, and that has to change. All of these things are impeding our ability to do some really cool stuff in tech. If you're a gamer and you want to see the boundaries pushed in gaming, this should matter to you, because we're essentially just neutering our ability to write cool games that you've never seen before. We're making it impossible for us to do that. If you're a programmer who cares about their craft, this matters to you. If you're a business that wants to make money, this matters to you. If you're a consumer who relies on things like even the software running in your car, for example, this matters to you. All of these things have an impact, and everybody should care about whether or not programmers, at the very least, programmers are being given the space they need to push the boundary in tech. And right now, it's the exact opposite. In mass, what's happening right now is, don't worry, AI will solve problems. Don't worry, we'll solve performance issues later. Don't worry, we'll fix bugs later. Don't worry, we'll plug security holes later. Don't worry, just do this thing, turn off your brain, provide business value, and consumers don't even have a way to properly complain about it because they're just completely desensitized by just massive amounts of issues and bugs that become common, just normal everyday occurrences. You don't even think about it. I bet you if you spent 1 hour while you're using your computer or your phone and you actually the friend part of your brain was very consciously paying attention to the things that irked you during your usage, you would see that there's a lot. But anytime you bring it up as a consumer, you're told, yeah, but you know what? We're using AI. These things are complicated. Like, it's just the way it is. Don't worry, things will get better. What everybody is being asked to do is have faith in a future thing when all the historical data and current data is showing that we're in a bad place. And it's only headed to further bad. It has to change. And until there's enough of a shift in the industry for it to change, I will continue going on these rants and making these long hour videos going over all this kind of information. Because If people like me don't do it, nobody will. And there's not very many people doing what I do. So I'm going to try. I'm going to give it my best shot. Thank you everyone for watching. Thanks to the live viewers who watched during the making of this. This is going to be a video. I really appreciate all the viewers and whatnot. Thank you for watching to the end of the video. If you managed to make it to the end of this long ass video, I appreciate it. Peace out. We'll see you soon. Okay, that's it. That's it for me. That's my conclusion. Okay, I'm gonna go back to my life. I wasn't even gonna stream today. Listen, folks. I am on Discord. What I might do is, I might just hop on Discord and just kind of like work there. And I would stay on and work on the Ship Chess game, but it's all boring code. Like nothing's going to happen. We're not going to be really working on anything exciting. We're not going to be adding much story, if any. It's a bunch of refactoring, cleanup, etc. to pave the way for the fun stuff. So I can't even like justify that. So I'm probably going to hop on Discord after this, probably in the next 20 minutes or so. So if you want to hang out on Discord and tell me I'm an idiot or whatever, do that, and I'll just work and chat with you guys. Yeah. Okay. Thanks, everybody. Just in case, is there anybody else on that side of things? No, we're good. Okay. Let me find someone to raid. Have a nice weekend, Vincent. I appreciate it. It's good to see you again, man. Glad to see that you're doing well. Gotta find someone to raid this again. We could go over to Sfei. We could go over to Chris. Man, I haven't raided Sfei in a while. I bet you Sfei is gonna be finished soon though. What's the problem? Let me see. Cozy, blah, 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 super time. What's going on? Is Twitch programming gonna start becoming just like full of degeneracy? We're definitely not gonna raid Theo. Just saying, we're not gonna be raiding the Theo, you know what I'm saying? You feeling me? Development. Oh, we're gonna raid Adam. Oh, 100% we're gonna raid Adam. Yeah, 100% we're raiding Adam. Adam is great. He is using C#, okay? So, you know, there might be a source of contention there, but genuinely, Adam is he's a great guy. He's always been a good supporter, and he really cares about the games he makes. And and even regardless of what language or whatever he's choosing, his games are cool, and you learn a lot from him. So Adam is just like a straight up cool guy. So we're gonna raid Adam. All right, I'm gonna start that. Okay, listen. Thanks everyone. You guys are all awesome. I appreciate it. Make sure to say hi to Adam properly. And definitely give him a little, make sure to watch him for a while. You won't regret it. Peace. I'll see you on Discord later.